Hey guys, trust you're all doing good. So, warm welcome to the lecture. So, today we'll discuss some of the fundamentals of functions. Hope you will enjoy this particular lecture as we go along. So, I will try and brief you about the basics of functions. There are so many facets, there are so many elements in functions. So, I wonder, we'll be able to cover all of that in one go. But let me help you with as many concept as I could through this particular period of next 100 or 120 minutes. Right. So if you want to take a look at what are the things that I may be willing to discuss today. So I have the desire to complete all of this. So that is what is the scope and important of this particular lecture. Then relationship. There are about dozen elements. Technically, if you look at it, there are about dozen elements. I will touch each one of them maybe. So that's the objective. I will touch all these dozen elements, and that does not end with the dozen elements. Naturally, there are much deeper aspects than these dozen elements, which I will update you towards the end of it. But the desire is to complete these dozen elements at least in the given period of time. So as you understand, this is one of the very important topics, no doubt, because it has so many elements in it, and then you generally get about a couple of questions from this particular topic. Two is generally a norm. You should get about two questions. So sometimes it could be little more, sometimes less is generally not, but it's generally little more than. So what? Well, a little more than two. At times, two is the general norm. Two questions is the general norm in most of the exams. Right. So therefore, keeping that in mind, it's important to understand a couple of elements, couple of basics of the functions. All right, so let's get started. So what we'll also do is first let's try and understand the definition. What is a relation and a function? So first let's start here on the relation and a function. And as we go along, let's try and understand what are the various other elements. So let me call it something like this. A relation is something like, say, if I have an element x, if I have a set x, let's call this as a set x. Yeah, let us call it as a set x, and I have a set y. Some of the school books might have talked about a b sets as well, whichever way they would have spoken, doesn't matter. So there is now there is a relationship, or there is a link associated between x and y. Assume that these are the elements here, 1 2 3 4, and here I have a b c d. Let's call these elements as ABC. Now this is the set. Basically it's a set. X is a set, nothing but a set. X is a set. What are the elements of this particular set? 1 2 3 and 4. It's a set. Y, what is y? Y is another set. What are the elements of this particular set? A comma b comma c comma d. Is it necessary that both of them should have 4 elements each? It's not necessary. I'm not talking about it. Just I've taken this as an example. See, relationships are 4 types. So relationships can be many. Relationships can be many to many, or let me start with one to many. One to many. Then we may have many to many. Then we have one to one, and one to many, and many to one. Now, these are the 4 relationships that you would have studied in the high school, right? In the high school, these are the four relationships you might have come across in the high school. These are the 4 relationships. Hey, what is the first one? What do you mean by one to many? One corresponds to this particular set. Many corresponds to this particular set. I've written in that particular order. One to many. One of the examples can be something like this. One to many. All right. Now, so this is a relation. All right. Now, this is also a relation. All right. This is also. All right. Now, say this one to many is an example of one to many. One element has many relations on the set y. All right, now there is a set x. There is one value of x here. One of the values here has 3 relationship with respect to y. For example, therefore that becomes a relation. That is not a function. All right, that becomes a relation. One to many. If one element has many values, which means you give one input value of x, it is giving you, it's throwing out multiple values of y. All right, you gave one value there, which means there is an equation. F of x is equal to whatever. All right, you have a function. You give one value of x. It started giving you multiple values of y. It is giving y1 as an output, y2 as an output, y3 as an output. You are surprised, man, what's happening with this equation? I just gave one value of this x, and it is giving out, all right, now multiple values of y. That's what you mean here. A is an answer, B is an answer, C is an answer. Therefore, you are surprised. What is that? All right, it is giving so many different answers. Now, therefore, that becomes a relation. All right, therefore, this is not a function. This is the relation. Because if you give one value of x, it should not give so many values of y. All right, that's the whole point there. Therefore, that becomes a relation. Similarly, many to many. Many to many is also a relation. So now this is all it. No, this is nothing but one to many. So this one element has many links here. It has many links here. Many to many is nothing but another chaotic situation. Many to many is what? This has a link here. Say something like this. All right, this has a link. Say all right, now this has a link out here, this has a link, now this has a link, and this is linked with this is linked with this is also linked with this. That's a complete chaotic situation. In the sense, if you look at 2 has 2 mappings. If you look at 3 has only one mapping. If you look at 4 has 2 mappings. Many to many, which means if you look at C, if you look from the perspective of C has 3 mappings. C is mapped with 1. All right, C is mapped with 1. C is also mapped. All right, C is also mapped with 3. C is also mapped with 4. All right, if you look from C's perspective, go backward. C is mapped with 1. C is mapped with 3. C is also mapped with 4. All right, therefore I'm calling this as many to many. This is also a relationship. This is also a relationship. Why? Because you give one input of X called 4. It has given 2 outputs here, C and D, something like that. Right? Therefore, that's also nothing but a relationship. Now, the remaining 2 are functions. 1 to 1 is a function. Many to 1 is a function. 1 to 1 and many to 1 are functions. Let me explain this. What are these functions therefore? Well, firstly, function is what? If you give one input value of X, it should give one output value of Y. That's important there. Take any equations. For example, if I take f of X is equal to 2x square plus 3x plus 7. I just took a quadratic function here. If I give one input value of X, if I put X is equal to 1, f of X is nothing but Y, my friends. F of X is nothing but Y. Y defined in terms of X is called as f of X. What is f of X? F of X is nothing but Y. Now, actually, if I want to write another variable for it, I will call it as a Y. Y defined in terms of X, that's what we call it as f of X, which means the coordinate, the value of Y expressed in terms of X, explicit function. Basically, explicitly, Y has been explicitly expressed in terms of X. That's a point there. If I give one value of X here, if I give X is equal to 1 here, if I give X is equal to 1 here, you will get only one value of Y. You will get only one value of Y, which would become 12, which would become 12. If I put X is equal to 1 in this, you get the output as 12. You will not get 12 as an output. 13 is also an output. 17 is also an output. No, you don't get so many outputs, only one output, right? But second thing is what? For every input, you have an output. It is not that, okay, now I will put X is equal to 0. Hey, there is no output now. Come on, whatever the input you give for X, whatever the real value that you put for X, you always have an output for Y. Right? That's the meaning of the function. Meaning of a function means there is only one output. For one input, there is going to be one output. You give one input for X, which means if you put X is equal to 1, you get one output here. Put X is equal to 0, you get exactly one output here. All that you get as 7. Likewise, you put an input, you get only one output. You get one corresponding output. That's point number 1. All right, that's point number 1. Second one is what? Every input has an output. Every input has an output. It can never happen that, okay, I give the input as 5, I'll put the X value is equal to 5 in this particular left right hand side, and surprisingly there is no output here. No, that won't happen. Right? That won't happen. For every real input, there is going to be an output. That is what you mean by a function. That's a definition of a function. Simply put, that's a definition of a function. Okay, let me redefine this. Let me come back and redefine this, what I meant by this. Let me redefine what I'm trying to say. Okay, therefore, if I'm writing this as a function, one should have a mapping. All right, now because one is an input must have an output, okay, and exactly one output. You can't say that one gives me output as B also and C also. No, it gives exactly one output. Assume that it is B. It's an assumption. Assume that it is going to be, okay. What about 2? 2 is giving me the output as D, okay. Hey, what about 3? 3 is also giving me output as D. That's fine. All right, that's fine. All right, 3 is also giving me output as D. All right, that is all right. Now, for example, if I take f of X is equal to, all right, f of X is equal to X square. I'm just writing it as an X square. So that's itself is a function. Okay, what is that you are trying to say? Y is equal to X square. You gave all it. Now you gave the input as 2. You gave the input as 2. What is the output, friends? 4. Okay. You gave the input as minus 2. What is the output, friends? That's also 4. So which means, can the two inputs have the same output? Yes. That's something like that. 2, the input is D. You gave the input as 3, the input is still D. That's possible. But if when you give 2 as an input, it cannot have multiple outputs. Output is 1. But can there be a common output? Yes. All right, there can be a common output. Then you looked at 4. The 4, all right, 4 gave me an output as C. 4 gave me an output as C. Is this a function? Yes, this is the function. function. All right, this is a function. Okay, this is nothing but a function. Why? Because every input has an output. One is an output input, you have an output. For 2 you have one output. For 3 you have one output. For 4 you have one output. But you may wonder that, hey, but A is not linked with anything. That's all right. All right, A not linked is fine. You don't look at Y and say that, hey, one of the elements of Y, which is A, is not associated with anything. That is not a problem. All right, that is not a problem. So point is, every element of X should have exactly one association in Y. Every element of set X should have exactly one association in Y. That is called as a function. Simply put, that is called as a function. Good. Okay, now why I'm talking about this, I'll come to it in a while. Firstly, what is domain? The domain means the values X can take. The domain, the meaning of domain. I will come back to this at the end of the lecture. For time being, just understand this definition. Domain is nothing but values X can take. Values X can take, because I'm going to write some equations. In that equation, every value cannot be taken, right? So therefore, values X can take is called as the X can take is nothing but the domain. Okay, what is the range? Range is nothing but the values Y can take. All right, values Y can take. Okay, now these are two important ones. Codomain as a word is not very important to us. Let me explain it here, friends. If I ask you what is the domain here, the domain here is nothing but values X can take 1, 2, 3, and 4. Here in this case, what is the range here? The values Y can take. All right, values Y can take. Y can take A, Y can take B, Y can take C, and Y can take D. Values Y can take. It's not, it has already taken. Y can take is called as Y. It's called as a range. Okay, what is codomain? The values Y has already taken, which means what are the values Y has already taken? It has taken a value B, it has associated with a value C, and it has associated with the value D. It did not take the value A. It did not take the value A. Therefore, codomain is BCD, which means if I were to write a codomain here, the codomain in this case is nothing but B, C, D. What is range? Range is nothing but A, B, C, and D. All right, range is nothing but A, B, C, and D. Okay, let's keep this much in mind for now. Let's keep this much in mind. What did we discuss? We understood what's a relation. We understood what is a function. We understood what do you mean by domain, what do you mean by range, what do you mean by codomain. Right, that's first 2 points we tried to understand here. Even if it has made very vague sense to you, already you don't have taken math in your 11th and 12th standard, and then therefore already you have forgotten quite a bit of math and algebra. Don't bother about it. As we go along, things would become clear. You need to just hold patience, have patience, and just hang around there. Just hang around there. You'd be able to understand as we go along. Because sometimes when the journey has just started, so a lot of things look gray. A lot of things look gray doesn't mean that you give up, right? No, so you don't give up. So wait, all right, now wait. The things will turn from black to gray to white. All right, that's a natural sequence. All right, because if the background is good, naturally it would appear white from black to white. All right, it suddenly look white. But if the background is not strong with respect to a particular topic, what happened? It passes through a shade of grays. All right, it goes through the shades of gray there. Right now, that's what happens there. Fine, let me come to this. Let me come to the third point here. What is that? First way of classifying the functions is what? 1, 1 and many 1. First way of classification of function is there are 1, 1 functions. First way of classifying 1, 1 function. A given function should be either 1, 1 function, or the given function should be a many 1 function. One of this has to be a function. Given function has to be a 1, 1 function, or the given function has to be a many 1 function. I will tell you what I mean by 1, 1 function is something like this. Say I have a set X. The elements of set X are nothing but 1, 2, 3, 4. I have another set Y. The elements of set Y are A, B, C, D, E. Call it A, B, C, D, E. Okay, what do you mean by 1, 1? So 1 has a link with B. Assume that, okay, 1 has an association with B. 1 has an association with B. 2 has an association with D. 4 has an associated with E. 3 has an associated with A. Now this is called as 1, 1. Why? Because now if you look at any element of X, it has a single association in Y, but it's a distinct association is Y. The word is distinct. It has a distinct association in Y. Every element of X has a distinct association in Y. All right, that is why I call it as, because if you say that A is associated only with 3, A is associated only with 3, no, nothing else. All right, nothing else. It has a distinct association. You may say that, hey, one of the elements of Y is not associated. That's okay. Is every element of X is associated or not? That's important, because for every input value of X, there must be an output value of Y. That's important there. Right, therefore, is it associated already? If every element of X has an answer or not? Yes. But is that answer unique? Yes. The answer is also unique. The answer is also unique. Therefore, you call that as a 1, 1 function. The given function, you call it as a 1, 1 function. For example, if you write y is equal to 3x plus 4, if you write y is equal to 3x plus 4, so what happens? For every value of x, you will get a unique value of y. No two values will be same. For every value of x, you are going to get a unique value of y. It is called as a 1-1 function. Now that is called as a 1-1 function. Technically, that is the meaning. All right, from the diagram, this is called as a 1-1 function. Now remember this. Now what can be a kind of a question that can be asked? Firstly, all right, now, so what is many one? Let me explain that. Then I will come back to this. This is 1-1 function. Let me put the same diagram. Let me explain many one function as well first to you. Let me explain many one function as well. Many one function, that is one way of classification. One way of classification. 1-1 and many one is one way of classifying the data, right? Okay, now we have a b c d e, right? Now set x and y, set x and y, a function is defined from set x to set y, set x to set y. Okay, what is many one? Many one can be something like this. 1 is linked with b, 2 is also linked with b, 3 is linked with C, 4 is also linked with C. All right, 4 is also linked with C. This is called as many one. Why? Many elements of X has a single association in Y. Many means what? More than one. More than one. Is it 2 or 3 does not matter to me. All right, more than one. More than one. This is called as a many to one. Many means what? At least one pair. All right, it can be one like this. There is no problem. You may say that, okay, this has having a link like this. It is still a many one function. Why? Because both 1 and 2 are associated with one element of Y, which is nothing but b. This is called as many one function. This is called as many one function. All right, I hope everybody is understanding this. 1-1 and many one, right? 1-1 and many one, which means the responses need not be distinct. The responses are not distinct here. The responses are not distinct, which means some of the responses have the same answer. 1 and 2 together have the same response when it comes to set y. When it comes to set y, this is called as many one function. Okay, now what can be the kind of questions which come in any exam? Having understood the classification, having understood the definition, domain, the range, and then understanding of the one way of classification, that is 1-1 and many one, what can be the questions that can be expected in the exam? Let's understand that. What can be the question? Now 3 questions. Let me ask you 3 questions on this. All right, let me ask you 3 questions on this. Okay, so I can give you this particular set. I can give this particular set out here, just like I did here. I may have this particular set. Just a second, friends. So let me ask you a couple of questions, because we need to understand, okay, so after doing this, what is expected out of this in the exam, right? Always that's important. Simply learning does not make sense, right? So we also need to understand that, okay, what is the expectation? Okay, why are we doing all this? What is the need for all this? Let's understand. So now I can say that, okay, there is a function defined from x to y. There is a function which is defined from x to y. Now I can ask a couple of questions. Number one, firstly, I can ask that, okay, how many functions are possible? How many functions are possible from x to y? How many functions are possible from x to y? That can be my first question. How many? Question is, how many functions are possible? Is it 1 function, 2 function, 10 function, 100 function? How many functions are possible from x to y? That's one. Number 2, how many one-to-one functions are possible from x to y? How many one-to-one functions are possible from x to y? Now these are the kind of questions asked in the past, right? Now based on understanding of this, they will give a set x here. They will give something like this. All right, don't expect this figure. So rather they will give like this. There is a set x which has 1, 2, 3, 4 as the elements. 1, 2, 3, 4 are the elements of the set x. Then they will write set y. The elements are a, b, c, d, e. All right, now they may give like this. One of the questions can be asked. I'm asking 3 questions on this. What is the first question? How many functions are possible from x to y? How many one-one functions are possible from x to y? Number 3, how many one functions are possible from x to y? I'm asking all 3 of them. In the exam, you can expect one of these questions with some restrictions. Now, what is the fundamental behind this? The fundamental behind this is PNC. All right, fundamental behind this is PNC, in the sense, okay, I need to have an understanding about function, no doubt about it. I need to have an understanding. Now, after having that understanding, I also understand that how do I count? Counting principles comes from your PNC lecture, right? I've taken the lecture on PNC. If you just go back and refer to that, you will understand, all right, now most part of it, what I'm talking about, what I'll be going to talk here, right? Okay, let's take a look here. So therefore, what do you understand here? You take the first element. First element 1 can be linked with either A or B or C or D or E, because there is an element called 1. 1 can have a mapping with either A or B or C or D or E. Therefore, you're saying that element 1, all right, now that's point x, because what is my reference 1? My reference is the elements of elements of set x. They are my reference. Therefore, I looked at 1 there. 1 can be mapped in 5 ways. First question I'm doing, friends. 1 can be mapped in 5 ways. Okay, assume that you mapped 1 with b. All right, 1 with b. Now you looked at the element 2. You looked at element 2. 2 can be mapped in how many ways? 2 also can be mapped in 5 ways. 2 also can be mapped in 5 ways. Why? You look at 2 and you can say that a 2 can be mapped with a, b, c, d, or e. Anything is fine. It can 2 also give the same answer? Be possible. Possible. All right, possible. 2 answer can give the same answer. It should give one answer. That's it. When you give the input as 2, it should give one answer. So can that answer be same as the earlier answer? Of course it can be same as the earlier answer. No problem. All right, therefore you will say that element 2 also giving the same answer. Therefore possible. Therefore including all of them. Can it give a as the answer? Yes. Can it give b as the answer? Possible. Can it give c as the answer? Possible. All right, therefore you would say that it can give any of the 5 answers. I hope by now all of you got this response here. Therefore element 3. What about 3? 3 can also be mapped in 5 ways. 4 can also be mapped in 5 ways. All right, 1, 2, 3. For each element can be mapped in five ways. All right, therefore you say that the answer to the first question is nothing but 5 raised to power 4. Answer to the first question is nothing but 5 raised to power 4, right? 5 raised to power 4. Therefore, all right, now it's basically what counting. Can we generalize if it has m elements, if it has n elements? Yes, but all that is not required. Just it's a PNC here. Don't try to remember formula and get confused between m, n, ap, pq, rst, all of that. Don't confuse. We know the simple algorithm. We already learned in PNC. Just use that application. You understand the total number of functions are 5 raised to power 4. 625 functions are possible, friends. You will think like that, right? Now, just 4 elements here and 5 elements here, right? Now such small numbers, such simple sets. So now you are saying that, man, there are 625 functions which are possible between them. Yes, that's a truth. That's a truth. Now I'm going to write the breakup. Now I'm going to write the breakup. That's about the first part of it. First part of it is nothing but 625 functions are possible. Question is, next is, how many 1 functions are possible? How many 1 functions are possible? So first I will take up the element 1. I will take the first element 1. 1 can be mapped in 5 ways. 1 can be mapped in 5 ways. Okay, so let us say that 1 is mapped with b. 1 is mapped with b. What about the element 2? Now we are looking at 2. Can 2 be mapped with b? No, 2 cannot be mapped with b. 2 can be mapped with any of the remaining 4 elements of set y. B2 can be mapped with any of the 4 elements. Okay, so therefore let me map it with d. All right, so therefore b and d are gone. So when you look at the element 3 of set x, can it be mapped with b and d? No, it can't be mapped with b and d. It can be mapped with the remaining 3 elements, that is a, c. Say that okay, 3 is mapped with c, so on. All right, therefore it can be mapped in 3 ways. Hey, what about the fourth element of the set x? That can be mapped in any of the remaining 2 ways. Therefore you are trying to say that 5 into 4 into 3 into 2, fundamental principle of counting, which I taught you in PNC. Therefore you say that, hey, this is nothing but 120. All right, this is nothing but 120. So you are saying that answer to the second question is 120, right? 120 ways. This can be mapped in 120 ways. Second question can be done in 120 ways. First question 625 ways. Second question 120 ways. If they ask you many 1 functions, look, the given function should be either 1 function or the given function should be a many 1 function. Therefore, if I ask you the many 1 function in the exam, you got to do the total number of functions minus 1 function. That is the way to do the many 1 functions. If I ask a question on many 1 function, get the total, friends. The total is 5 raised to power 4 and number of 1 functions are nothing but 120 out of this. 625 minus 120, right? That's 505. That's nothing but the remaining many 1 functions, which is nothing but 505. All right, which is nothing but 505. That becomes the many 1 function. There is no direct way to find the many 1 function. The best way to find the many 1 function is number of total number of functions minus number of 1 functions gives the many 1 function. Therefore, most of you would have judged by now. So what are the 2 questions that they generally ask in the exam is either they ask total number of functions or they ask the many 1 function. That's what I generally see observed in the exam papers. So therefore, what is that now? So what are we trying to understand here? First, we need to understand the definition of function. Once you understand the definition of a function, the second point that comes in the picture is, well, how do I count the number of functions, the 1 functions and many 1 function? Okay, the second way of classification. This is the first way of classification. All right, what is the second way of classification? The second way of classification is onto functions and into functions. That's the second way of classification. Second way is onto and into. Just like a triangle, my friends, triangles are classified in 2 ways. Triangles can be classified based on sides. Based on sides, you will say that, okay, scalene triangle, isosceles triangle, and then equilateral triangle. That is what? Based on sides. Triangles can also be classified based on angles. Triangles can also be classified based on angles. Based on angles, how do you call it? Acute angle triangle, right angle triangle, obtuse angle triangle, something like this, right? Obtuse angle triangle. That's based on angles. Similarly, the functions can be classified classified in two ways. Right? Functions can be classified. One of the ways is what? One function or many one function. Either it should be a one function or it should be a many one function. The second way is either it can be an onto function or into function. Into function. There are two ways of classification. Now these are the four words you should be clear with. One you should be clear, many one you should be clear, onto you should be clear, into you should be clear. Not only clear about the definition, the idea of being clear with them is to count the function. The basic objective is to count. You need to count how many functions are there. Well, that's idea there. That's idea there. Therefore, first let's understand, then let's count, and then we are clear with this. Then we'll be clear with this. Okay. What do you mean by onto function? Onto function is something like this. Say, for example, if I have the set x as a, b, c, d, say that these are the four elements of set x. Well, let's say set x. All right. Now then I have the set y. Set y. I have three outcomes. 1, 2, 3 as the outcome. Okay, what do you mean by an onto function? Now listen carefully here. What do you mean by an onto function? Onto function means no element of y should be empty. No element of y should be empty. Anyway, no element of x will be empty, because if any element of x is empty, then it is not a function at all, because every element of x should have an answer. If in case the no element of y is also empty, which means every element of y has a pre-mapping in x, if that has a mapping, then we call that as an onto function. For example, let me show it here. 1 is linked with 2, let's say that 1 is linked with 2, B is also linked with 2, D is linked with 1, and C is linked with 3. All right, is every element of, all right, anyway every element of x will have a mapping, otherwise it's not a function at all, right? Every element of x has a mapping. That's right. Okay, now in this case, what is the second thing that you have ensured? You've ensured that every element of y also is engaged. Every element of y is also engaged. Not only the elements of x are engaged, elements of x must be engaged. Every element of x must be engaged. There is no choice in the matter. But every element of y is also engaged. That is called as an onto function. Onto function. Now let's take the same example. So thereby you would have got the meaning of the into function by now. Alright, in your mind you would have got the meaning of the into function. Technically, I guess most of this you study during the 11th standard. Of course, you might study a little bit about the high school, but high school is not too much about this. So anybody who had done the math in the 11th standard, I'm sure all it now these are pretty simple ones. The counting also, already you would be familiar with what I'm talking here. Yeah, what is an into function? Therefore, this is an onto function. This is an example of onto function. So what is an into function? At least one element is not mapped. At least one element of y is not mapped. It's not having a pre-image. That's which one element of y is not engaged, or it is not engaged with the element of x. All right, that's called. For example, let's say that okay, a is mapped with 2, b is mapped with 2, c is mapped with 2, d is mapped with 3. Okay, now which element is not engaged? One is not engaged. Because one is not engaged, this becomes an into function. It's a function. Why? Because every element of x is engaged, no doubt, but one of the elements of y is not engaged. Therefore, I'll give a name as into function. This becomes an into function. All right, this becomes an into function. Right, this becomes an into function. I hope everybody is clear with this. All right, everybody is clear with this. Let me take a simple example. Let me give a simple example on this, friends. Let me take a simple example on this. Let me take a very simple example just to illustrate how some of the questions have looked in the past. One of the questions have looked in the past. Let me take, all right, this set x. So they may not give a figure. They write it as a set x. Okay, set x, the elements of set x are a, b, c, and d. The elements of set y, and there is a function defined. The element of set y are only two numbers, 1 and 2. The elements of set y are nothing but only two numbers, right, which are nothing but 1 and 2. One question that I can ask is, how many onto functions are possible from x to y? How many onto functions are possible from x to y? How many onto functions? Only one question I'm asking. How many onto functions are possible from x to y? What do you mean by onto function? Onto function means both the elements of y should be engaged, right? Anyway, in a function, all elements of x will be engaged. Now you need to make sure that every element of y is also engaged. Of course, there are only two elements here. You need to ensure that both of them are engaged. How do you ensure this, friends? The best way to do this is, all it onto, generally you get a question on onto. The best way to do this is again onto number of onto functions are total functions minus into functions, because the given function should be either classified as an onto function or into function. This is one classification. One and many one is one way of classifying. Onto and into is another way of classifying. Onto and into is another way of classifying, right? That's right. Okay, so therefore total minus into functions gives me the onto function. That's a way to figure out the number of onto functions. All right, how many total functions are there? Total number of functions. All right, now look at this. A can be engaged in how many ways? A can be engaged in two ways. Why? Either it can be engaged with one or two. Similarly, B can be engaged in how many ways? The B can be engaged in two ways. And the element C can be engaged in how many ways? Two ways. The element D can be engaged in how many ways? Two ways. Therefore, together, totally how many here? 2 raised to power 4. 2 raised to power 4. That is total number of functions possible are 16 functions. 16 functions. Out of which, how many into functions are possible? Assume that every element is associated with C. Every element is associated with 1. A, B, C, D are associated with 1. That is 1 into function. I'm showing the number of into function, friends. Number of into functions. What is this into function? This is an into function because element 2 is not engaged. Element 2 is not engaged. Okay. Can I have another into? I can have another into function. I will show it to you. There are only 2 into functions possible. What is the second into functions? Like this, every element is engaged with 2. All the elements are engaged with 2. Therefore, which element is not engaged now? The element 1 of y is not engaged. Therefore, I am getting another into function. That's it. Are there only 2 into functions? Of course, yes. There is no third into function. Third into function, only 2 into functions. Therefore, how many onto functions? 16 minus 2. Number of onto functions are 14. Total number of functions are 16, of which 2 of them are into functions and the remaining 14 are onto functions. Okay, point is very clear. If you are clear with your counting algorithms, you can count one functions, you can count many one function, you can count onto function, you can count into function, you can count both one and onto function. If you need to have a one and onto functions, the number of element in set X should be same as number of elements in set Y. Number of elements in set X should be same as number of elements in set Y. Only then one and onto functions are possible. Otherwise, one and onto functions are not possible. If the number of elements in set X and number of set elements in set Y both are equal to K, number of one onto functions are nothing but K factorial. Number of one onto functions are nothing but K factorial. If I club, what conditions I'm clubbing? If I club one here and the onto from here, if I club these two conditions, generally that's another type of question which comes in the exam. If I club these two conditions together, then there has to be first condition. I can club provided number of elements in set X are equal to number of elements in set Y. Otherwise, it's not possible. Otherwise, one and onto together is not possible. What is the answer here? Answer is going to be K factorial, provided there are K elements. Now look here. In this question, one onto is not possible. One and onto, two conditions. One and onto is not possible in the given question. Reason? Yeah, you have 4 elements in set X and you have 2 elements in set Y. 4 elements need to have at least 4 mappings on the other side, right? So with 2 elements, it's not possible. It's not possible. Therefore, if I can increase this to 1, 2, 3, 4, if I increase this to 1, 2, 3, 4, now the one onto functions are possible. How many elements are there, my friends? 4 elements each. There are 4 elements. My answer is going to be 4 factorial. My answer is going to be 4 factorial. Simple. We know that A can be mapped in 4 ways. Assume that A is mapped with 3. Assume that A is mapped with 3. Something like this. A mapped with 3. Because it has to be 1, 1. It has to be 1, 1. Next, what you will say? B has to be mapped in the remaining 3 ways. Assume that B got mapped with 4. C got mapped with 1 and D got mapped with 4. Therefore, 4 into 3 into 2 into 1. So now by doing that, are all the elements of Y got engaged? Yes, it got automatically engaged. Reason being, the number of elements in set X and set Y are same. Okay, now this is one type of question. I have already taken about 30 minutes to illustrate this first type of question which comes on the functions. First type of questions, that is counting the functions itself. 4 terms are important. What do you mean by one? What do you mean by many one? What do you mean by onto? What do you mean by into? Okay, that has taken 30 minutes of my lecture. Let me go further. Now let me introduce few more elements before I jump to questions built on function. Another set of questions built on functions. Let me first introduce some of these elements out here. Some of these terms let me introduce. Let me introduce some of them. First, composition of function. What is composition? Mixing them together. All right, clubbing them together. Composition, composite. All right, you make a cement composite. Means what? You make cement with sand and a little bit of stones or pebbles or whatever, right? So that's, you make a cement composite. Cement composite. Same way out here. Composition is nothing but the mixing of the functions, bringing together the function. One way of representing that thought is this. This is one way of representing that particular thought. F O, all right, no, this is F. All right, technically that O should be small. F O G O H of X, something like this. You write something like this. That's one way. Same thing can also be written as F. This O can be replaced by a bracket. This G can be G, and then this can be replaced by a bracket. H of what? X. Then close it, because there are three brackets here: 1, 2, and 3. Therefore, one here, the second one here, and the third one here. Close it by using the three brackets on the other side as well. On the other side as well. So what does it mean here? So what it means is here is h of x should be the input. H of x should be the input to the function g. H of x should be input to the function g. Let me do it here, friends. What is h of x here? X square. What is h of x here? Alright, h of x. See, first let me take it only till here. Let me take till here. Alright, g of h of x can also be written as till here. I'm doing it till here. Okay. So do I know the value of h of x? Okay, g of, alright, I'm writing it as g of h of x till here. I'm writing. Do I know the value of h, value of h of x? Yes. What is value of h of x? X square. Let me substitute. X square. Therefore, what is that you are trying to say? You are trying to say that I want to find what is g of x square. Now, do I know the function what is g of x? Yes. All right, I know that g of x is nothing but x divided by x minus 1. But what is author saying? In place of x, g of x square is what author wants. X square here, because there is an x square here. Hey, what is g of x square? In place of x, I should be writing x square. In place of x, I should be writing x square. Very good. That is g of, all right, now that is what has become g of x square. That is nothing but, so far you got g of h of x. G of h of x. G of h of x is nothing but, all right, now this circle, what I'm doing it here. You reach it this here. You reach it this particular place. Now what you are doing, I am giving this as an input to h, a function f. I'm giving this as an input to f of x, a function f here. So which means, say, what is the value of this here, friends? This is nothing but, all right, now this box here. This box is x square divided by x square minus 1. X square minus 1. That's a box. Okay. Now, do I know f of x? Yes. What is f of x? F of x is a reciprocal function, 1 by x. Good. So in place of, but instead what I have here, f of what is the input that I have? Input that I have is x square divided by x square minus 1. Okay. Therefore, 1 divided by, in place of x, I should be writing x square divided by x square minus 1. Essentially, it will become x square minus 1 divided by x square. This becomes my final representation. Final presentation of the required value is this. What is the final presentation? You are saying that if I do a composition of this function, this would be equal to, that is f o g o h of x would be technically equal to, when I mix all three functions here, I had three functions first, then I had the second one, then I had the third one. If I mix all of them, just like a cement, sand, and stones, already if you mix them together, how a concrete is formed. Likewise, the composite has been formed. Mixing all three of them, you said that, man, this particular function is nothing but x square minus 1 divided by x square. That is what it has become. Okay, you guys would have done all of this in the high school, no doubt about it. But my duty is to remember that to you, right? Because I need to remind, I cannot take it for granted. I'm just reminding you using one example, because we may need them in the future. We may need them as we start doing the examples in the future. So therefore, I'm just reminding you out here. So next value is what? F, G, H of 2. Okay, fine. Same answer here. So I already know my function. I already know my output. In place of x, I should put what? 2 square. 2 square. All right, now 2, I should put 2 square minus 2 divided by 2 square, which would become 3 divided by 4. Which becomes 3 divided by 4. That's the answer to the second question. Okay, so my point is pretty clear. How do you mix the functions? How that's called as a composition of functions based on the order. Now the order can be anything. All right, here the order was f o g o h of x. Hey, can I change it to h o g o f of x? Yes. Then your answer will change. If you do this, your answer may be something else, because the order matters. Order matters in a function. We can't do anything that will feel like mixing. Here, first input should be given with f of x. That input, whatever the input, you will give it to the g function. That's the second input. Then finally, you will give to the h function. Your answer would change based on that, right? Your answer would change based on that. Good. Okay. I hope all of you got my point here. All of you got my point here. Let me go further. I guess all right, now all of you got the point here. That should not be a concern. So just I thought of reminding you about the composition of function. Another point before we go further into the CAT kind of questions or any management entrance kind of questions. Another one more point. After that, I'm going to the questions now. I'll go back to the questions. Inverse of a function. Let inverse of a function to find the inverse of a function. Right now, how do I find the inverse of a function? It's a two-step process, right? It's a two-step process. It's a two-step process. What is given to what is the first, what is given to me? What is given to me is y is equal to 3x plus 2 divided by 4x minus 1. You may say that, hey, where is y man here? All right, now f of x is nothing but y only, right? I already told you in the beginning of the lecture, f of x is nothing but y. It's an explicit function. Y expressed in terms of x. Technically, that's what we are trying to say. Y is equal to 3x plus 2 divided by 4x minus 1. What is the step one? What I need to do? First, you need to write this as x in terms of y. X is equal to, write something in terms of y. All right, write this in terms of y. All right, I want you to write this in terms of express x in terms of y. Okay, how do I do that? All right, now manipulate it a little bit, cross multiply. 4x minus 1 times of y is also equal to 3x plus 2. Okay, so then this is nothing but 4xy minus y is also equal to 3x plus 2. Get all the x's on one side, friends. 4xy, get this. All right, now get this on the other side. Put these two on the other side, underlined ones. Minus 3x is equal to y plus 2. All it is also equal to y plus 2. Get all x's, keep all x's on one side, keep all the remaining y's on the other side. Okay, from here take x common. All right, now from this underlined bracket take x common. All right, x common. 4y minus 3 is also equal to y plus 2. Good. Then you are saying that 4, therefore x is equal to, therefore x is equal to y plus 2 divided by 4y minus 3. Did I achieve the objective? First step was what? First step was express x in terms of y. Did I do that? Yes, I have successfully done that, right? This is what you mean. Yes, we did successfully do that. That's a step one. Step one is that x is equal to y plus 2 divided by 4y minus 3, which means it was given to me y is equal to something. It was given to me y is equal to something. I ended up writing x is equal to something. That's a whole point there. All right, y is equal to something was there. I ended up writing x is equal to something. Now you got to do what? Replace x with y and y with x in this function. This is a step one. Step one is writing it like this. Hey, what is step two? Step two is replace. Just replace. Step one was this. Step one is nothing but express x in terms of y. What is step two? Step two is nothing but replace x with y and y with x. Replace x with y and y with x in what? All right, in the step one. In the step one, whatever you got in the step one, just do that. All right, now if I do that, what do I get here? In place of x, I will write y. In place of x, I will write y. In place of x, I will write y, and in place of y, I write x. Therefore, I write this as x plus 2 divided by 4x minus 3. Replace. Done. All right, now this is the final answer. This is the inverse of the given function. The given function was 3x plus 2 divided by 4x minus 1. Therefore, the inverse of the given function is x plus 2 divided by 4x minus 3. That's the inverse of the given function. So if they ask the inverse of the given function, remember it's a two-step approach. It is just a two-step approach. They would have given the function as y is equal to something. You better write it as x is equal to something. Once you write x is equal to something, replace x with y. Replace x with y. Okay, let's do another example, friends. Let's take another example. Let's take this example just to illustrate that point. Okay, what is given to me? Y is equal to, another time we'll find the inverse of this function. Y is equal to x square plus 2x plus 1. Y is equal to x square plus 2x plus 1. Okay, this is what is presented to me. Now I got to write it as what? X is equal to, I have to write in terms of y. That's a challenge that I have in front of me. Correct. So let us first understand this. Y is equal to x plus 1 whole square. X plus 1 whole square, because x square plus 2x plus 1 can also be written as x plus 1 whole square. Fine, I wrote this. Therefore, you would say that, okay, take the square root on both the sides. Okay, if you want to write it nicely, you can write it like this. X plus 1 whole square is equal to y. Take square root on both the sides. You will get x plus 1 is equal to root y. X plus 1 is equal to root y. Therefore, x is equal to root y minus 1. Okay, are you successful in writing x is equal to something? Yes, that's the first step. All right, you started off by saying that hey, y is equal to something. You started off by saying y is equal to something. The step one is you should end by saying x is equal to something. X is equal to in terms of y. all x is on the left hand side, all the y should push down to the right hand side. Therefore you end up writing this. Now do what? Simple. Second, this is the first step. What is the second step? Replace x with y and y with x. Therefore y is equal to root x. Y is equal to root x minus 1. This is the required answer. Alright, this is the required answer. Alright, this is the answer. This is the inverse of the given function. Whatever were the function given, if I ask you the inverse of the given function, it appears like this: root y root x minus 1. It appears like this. Alright, that's what this would appear like this. Good. I hope everybody got this point here. Everybody got this point here. Now I suggest I'll let now pull out your pen. So far I did not give you too much of a break. I spoke at length for about 40 minutes. 40 minutes. Now take this. Now pull out your copies. Pull out your copies. Take a pen and then find the inverse of the given function here. I will wait for 2 minutes. I wait for 2 minutes for you. I wait for 2 minutes. I'll wait for 2 minutes. All of you find the inverse of the given function. We already know how to find the inverse. Find the inverse of the given function. You have a function here, y is equal to, it's given to me, y is equal to 3x plus 2 divided by 4x minus 3. It's been presented here. I want you to find the inverse of the given function. All of you, push your pencils. Push your pencil on the copy. Get the inverse. Start. Don't watch here and there. Yeah, okay. Good, I guess all of you did this. I gave good 2 minutes for you because I felt like that's a time that you might require. You also need a short time to do yourself. Okay, so therefore you understand that you ended with the same thing. You started off by saying y is equal to 3x plus 2 divided by 4x minus 3, and you ended with the same stuff. Already you ended with right out there. Now this is called as the self-inverse function. This is called as the self-inverse function. Of course, the inverse is itself. Inverse of the given function becomes itself. Inverse of the given function is itself. If you are not getting exactly same, you might have to just rearrange the things. Alright, in the sense, some of you might have got it as y is equal to 2 plus 3x divided by 4x minus 3. Don't worry, 2 plus 3x is same as 3x plus 2 only. Both are same, right? Both are same. You just have to rearrange to realize that fact. That's it. Now this is called as a self-inverse function. Okay, good. So now this is one of the standard functions. What I wrote is one of the standard functions. Those who done your 11th standard math, you would have remembered some of the standards. This is one of the gold standards, right? This is one of the gold standards. What I meant, if the function is of the form, listen very carefully here, watch this. If the function is of the form f of x is equal to ax plus b divided by cx plus d. If the function, this is the shape of the function. Some function can have many shapes, right? F of x can also be written as ax square plus bx plus c. It is also a shape of a function. There is nothing wrong with this particular function. That's also a shape. Well, that's also a shape of a function. But I'm saying that if the function is of this particular shape, one of the standards, if the function, but I'm talking about this because a lot of questions, many times the question have been asked in CAT based on this particular function. Therefore, I thought that, okay, the self-inverse, this type of self-inverse function is important. This is one of the very self-inverse function. I'm talking not just about any function. I'm talking about the self-inverse function, right? Yeah. F of x is ax plus b divided by cx plus d. If this is the shape in this function, if you notice a plus d is equal to 0. If a plus d is equal to 0, then it becomes a self-inverse function. Then there is no choice for it to become a self-inverse function. Then it becomes a self-inverse function. Then it becomes a self-inverse function. That's a function. Now this is the condition. What is the condition? If a plus d is equal to 0, that's a condition. If a plus d is equal to 0, it becomes a self-inverse function. Now take a look at this function, my friends. Let's rewrite y is equal to 3x plus 2 divided by 4x plus of minus 3. That's how you would have written this function, because you want to write in this particular shape. What is the shape here? There should be a plus sign here and there should be a plus sign here. Good. If I write in this particular shape, that's how it looks here. What is the value of a here? This is the value of a. The value of a is nothing but 3. What is the value of d here? This is the value of d, which is nothing but minus 3. Is a plus d 0? Of course yes, because the value of a is 3, the value of d is minus 3. Therefore is the value of a plus d, finally is the value of a plus d 0? Yes, because the value of a plus d 0, it becomes a self-inverse function. Remember this. All right, now remember this brackets. Remember this, what I'm trying to say, because you often encounter these kind of self-inverse function. Okay, now the point here is, okay, if it is a self-inverse function, listen carefully friends, you can do that. Can I find f of x? Can I find f of x, which means this is called as recursive functions. Call the function inside the same function, that is called as the recursive function, right? F of x. Can I do this f of x? Yes. All right, yes. So let us try doing that. What is f of x? Let's try doing this. Okay, so now you have f of x is equal to 3x plus 2 divided by 4x minus 3. All right, 4x minus 3. Okay, what is f of x, which means I have to give f of x as an input, f of x as an input to the next function. Therefore what is the input, friends? This box is the input. Therefore you are trying to say that next one, f of 3x plus 2 divided by 4x minus 3. This should be input to the function. Hey, what is the function, by the way? All right, what is the function, by the way? The function is 3x plus 2. All right, now this should be the input given to the function 3x plus 2 divided by 4x minus 3. How does it look like? Therefore 3 times of. All right, now therefore the output looks like 3 times of. In place of x, you should be writing 3x plus 2 divided by 4x minus 3, because there is an x here. All right, there is an x here. In this place of x, I am substituting it. Okay, plus 2 divided by 4 times of 3x plus 2 divided by 4x minus 3. All right, then minus 3. You simplify this, you get the output as x. Therefore what I'm trying to say, that if it is a self-inverse function, f of x becomes x. All right, f of x becomes x. Now f of x, people also popularly write this as f square x. I'm writing this like this. F of x, I can write it as f square x. F square x is equal to x. That's a standard result. In any self-inverse function, f square x becomes x. All right, it becomes x. All right, that becomes x. All right. Therefore, what is f cube x? That is f of x, can also be popularly written as f cube x. All right, f cube x, all right, something like this. F cube x, nothing but f of x. Why? Because f square x is x. Now you are giving this function into another function of f. All right, another function of f. If I give that f of x, then answer will become what? F of x. Therefore what is that you are trying to say? Therefore in any self-inverse function, f raised to even power 2n, f raised to 2n times of x is equal to x, and f raised to 2n minus 1 times of x, that is the odd power, will be equal to f of x itself. F of x itself, where in self-inverse function. Now these are the 3 things I want you to remember. If the shape is this condition gives me the self-inverse function. In a self-inverse function, this proposition is true. What is the proposition? The even power, which means if the function is called even number of times, the outcome is going to be x. If the function has been considered odd number of times, then the output is going to be f of x itself. Now here are the 2 cat questions based on this. This is the cat question. All right, these are the cat questions here. I just took the function, I changed it. I changed only the function, and the rest of it I retained as it is. The rest of it retained, which means F100 to 2 was one of the questions. The 25, I don't remember, it was 1990s, 2007 or something like that, F raised to power 2007, some large number. Basically one odd, one of the years they asked about the odd, one of the years they asked about the even, one of the years they asked about the even. Firstly, is this the self-inverse function? Yes. All right, because the value of A is 3, the value of D is -3. Therefore, it's a self-inverse function. What do I know in a self-inverse function? In a self-inverse function, F raised to even power, F raised to even power times of X is nothing but X. It's a static function. X, it becomes just X. That's it. It simply becomes X. Therefore, F100 times of X will be X itself because it's an even power here. Second question I'm doing. F 100 times. If you consider that function 100 times, F100 times, F raised to power 100 times of X is nothing but X itself. Therefore, F100 times of 2. In place of X, I should write 2. Answer is 2 itself. That is the answer. Answer to the second question is 2. What about the answer to the first question? Alright, F odd. If you call this function odd number of times, consider it odd number of times, then the function output will be equal to F of X itself. Therefore, here F25 times of X. First, let me write X and then I will go for 3 here. First, let me write F. X25 times of X is nothing but F of X itself. Alright, what is F of X, friends? 3X plus 4 divided by 5X minus 3. That's what is given to me. Okay, therefore, F25 times of 3, which means in place of X, I should simply put this value 3 here. Therefore, 3 times of 3 plus 4 divided by 5 times of 3 minus 3. All right, 5 times of 3 minus 3. Therefore, that would become 10 divided by 12. All right, we can simplify, which becomes 5 by 6. Therefore, we all got the answer to these questions. All right, that's a response to this particular question. Simple one, simple one. So if you understand the self-inverse functions or something, probably you would have solved these questions in a jiffy. All right, when it comes to the sum of the exam, these were in fact the CAT kind of questions what I solved here. All right, typical CAT kind of some of the questions. Okay, I don't have time to take all types of questions, but at least let me make an effort to give the all right in the next 100 in the next 60 or 70 minutes, whatever the best patterns that I could see. Let me try. Let me show you all those possible patterns. Okay, let me go to the next question now. Let me go to the next question. Now, these patterns are very, very important in the functions. These patterns are very, very important when it comes to the functions. Let's take a look at this. Let's take a look at this. Try it, try it. Okay, anyway, you understood that, okay, you cannot call this function 10 times. Correct, we all know that. All right, 10 times you can't anyway call this particular function. Do it at least 2 times, my friends. Why don't you do already FO, F of X? Why don't you do at least 2 times? Right, FO, F of X, at least I can do, right? At least this I can do, right? So therefore, what, all right, now for a function of X, what is F of X here? Give that input, therefore it becomes F of X divided by 1 plus X. In place of X, I should be writing this. In place of X, I should be writing this. Hey, where is X here? Here in that place of X, I should write X divided by 1 plus X. Okay, 1 plus 1 plus, now another X is there. In place of X, I should give this input. I should give this input, X divided by 1 plus X. That is nothing but F square X. That is the, this is the output for the F square X. Okay, what is this, by the way? This is nothing but X divided by 1 plus 2X. X divided by 1 plus 2X. That's the outcome. That's the outcome. Okay, so likewise you might have done another one step there, another one step there. So therefore you will realize that F, now look at this, F of X, F1 of X, F1, F1X is given to me X divided by 1 plus X, right? Yeah, F2X, that is considering it 2 times. This would have given, this has given me X plus 1 or X divided by 1 plus 2X. I already found this out. I found this out, X plus 2X. I found it. Okay, now you in the exam you might have done once more. Already F3X is nothing but X plus 1 plus 3X. That's a pattern. That's a pattern. They may ask you 100 times of 3 also. Does not matter. Don't leave that question immediately because you find the number 3 there. Just to do one couple of things there, couple of terms, already you will get the value. Therefore, now you can generalize. Therefore, Fn of X. Therefore, Fn of X is nothing but X divided by 1 plus Nx. X divided by 1 plus Nx. Why? Because when there is a 2 here, alright, when there is a 2 here, you wrote 2 here. When there is a 3 here, you wrote 3 here. When there is a 1 here, you wrote 1 here. So therefore, already if it is n, you are going to write this n there. Already that's a given function. Now what author is saying? He is saying that, man, why don't you find F10 of X? F10 of X is nothing but X divided by 1 plus 10X. 1 plus 10x. Then you are saying that, okay, I will not x here, I want to put the value 3 there. F10 of 3 therefore is nothing but 3 plus 10 into 3. All right, therefore you say that the required result is 3 divided by 31. All right, 3 divided by 31, simple one, simple one. Just all right, now don't hesitate to make the patterns. They just take about a minute's time. Generally the questions and functions are either too easy or too difficult. All right, now what do you mean by too easy and too difficult? The fellow who quickly understands and has some knowledge about the given function, it is easy for him. If no knowledge, it becomes difficult for him. There is nothing intermediate in between the two. All right, in between the two. That's the beauty about the functions. You know what to do with it, quickly do it. It is easy for you. You don't know what to do it, don't fight with it. Go ahead to the next one. That's more often it is true with algebra. More often it is true with algebra. You know methods, you know what to do with it. Just put your head down, pen down, and then just start doing it. You'll be able to work it out. Right now, if you don't know about it, it becomes a research. Exam is not about research. A lot of my students keep doing this. I keep telling you, exam is about demonstration of skill. Don't try to do research work in the exam. If you really want to do the research work, finish all the demonstrations that are possible. The word is demonstration of your knowledge. All right, that is your exam. Exam is demonstration. What some people do is they will start pushing their pencil. They will look at the question. I kind of do this question, I can do this question. They will start wasting their time, 2 minutes, 3 minutes, 4 minutes, 5 minutes, ending nowhere. What is that called? That is called as a research. You are trying to figure out something there. Hey, don't try to figure out something there. Do you know it? You better do it. That's it. All right, if you know it, you better do it. Exam is about demonstration. Fine, let's say that 40 minutes is the section time. Assume that 40 minutes is the section time. In 40 minutes, I did all my demonstrations in 30 minutes. Okay, then do research for remaining 10 minutes. Don't intersperse the research and demonstration together. All right, then you don't have a clarity about what you are trying to do. That's what some people do. Some people mix up the research and demonstration together and they start getting frustrated in between. What is that you are trying to do? Research is when you are trying to figure out at the back end. You could do the research after the paper. After the paper, if you get to know the paper after some days, or if you remember the questions, then you do the research on that particular question. There is no problem. Take help of Google also to do that particular research. There is no issue on that. Right? Take help of your friends, take help of your teachers to do that research. But the point is, in the exam, don't sit and do it alone. Don't sit and do it alone. Exam is demonstration of what you know. I don't know. Then do the research full paper. The full paper is research for that fellow, because anyway, that fellow doesn't know anything. But if you know, you are busy demonstrating what you know. Identify the battles, identify your problems, start demonstrating. Don't start doing the research in the paper. That's not the job given to you there. Right? Okay, let's be very clear about that. That's what I mean by that. More often it is so true in algebra, because there is no, either you are doing the research or you are demonstrating. If you know the methods, you are doing the method, applying the method and getting the answer in no time. If you don't know the method, trust me, you are doing some research. Your mind is saying that, you kind of know this question. That kind of will not work. Do you know or don't you know? That's it. Be binary. In the exam, demonstration means be binary. It's a binary. All right, there is no gray area there. There is no gray area. Any gray area comes under the research paper. That research, do it once the demonstrations are over, because anyway the demonstrations are over. I hope all of you got my message loud and clear. All of you got this message loud and clear. Don't waste your time in the exam. That's my point. Okay, let's go here. Let's go to this. Another pattern, another simple pattern. Now take the clues. Sometimes you got to get the clues from the question stem as well. What is this here? F of 2 divided by f of 1 by 2. F of 3 divided by 1, f of 1 by 3, which means what? A number and its reciprocal, right? Reciprocal. So a function is given to me. Why don't I find the reciprocal of this particular function? Okay, let me put in place of x 1 by x. Hey, where you are getting this idea of reciprocal? Idea of reciprocal you are getting from the question stem. All right, you are not generating that idea. Question stem is asking the reciprocal. Therefore, let me check what happens if I do that. If I put that reciprocal there. Reciprocal means what? If the x value is 2, all right, this is going to be 1 by 2. All right, if this is going to be 1 by 2, nothing but x. You will always define it in terms of generalization. Therefore, you are writing it as f of 1 by x. All right. If I write this as f of 1 by x, what does this become, friends? This becomes 3 divided by x cube. All right, this becomes 3 divided by x cube. 3 by x cube. Then this becomes 2 by x square, because in place of x you are writing 1 by x. In place of x you are writing 1 by x. Okay, so this becomes 1 by x. Hey, what about the next one? Next one becomes x, because this is 1 by x, the reciprocal of that. It's a reciprocal function. It becomes this. Okay, hey, what about the next one here? What about this? This becomes 2x square. Hey, what about this? This becomes 3x cube. 3x cube. My point here is, if you observe both of them carefully, if you observe f of x and f of 1 by x, both are equal. Both are equal. F of x is equal to f of 1 by x. Same terms are there, just in the reverse order. All right, this term is matching with this particular term, and finally this term is matching with this particular term. Just the terms got reversed. All right, terms got reversed. The order of the terms got reversed. Therefore, both are same. If both are same, then what is f of x divided by f of 1 by x? F of x divided by f of 1 by x is 1. Therefore, you are trying to say that this property is 1 and this is going to be 1. Like this, finally this is going to be 1. So therefore, from 2 up to 10 there are 9 terms. Therefore the answer is 9. There are 9 ones for you. Therefore the answer is nothing but 9. Hey, this was a cat question. What I did is a cat question. Now it looks ridiculous, isn't it? You look at this question, hey, come on, all it is this the kind of question being asked in the exam? Yes. All right, now these are the kind of the questions sometimes being asked in the exam. But the point is, under the exam condition, they look really dirty. They look bad. Right now, out of the exam, things look beautiful. Why? Because there is a pressure quotient in the exam. Under pressure, this question itself is enough for half of the people not to solve this particular question because it doesn't look good. The cubic equation doesn't look good. The quadratic, a lot of them will feel like doing it. The moment they look at a cubic and then reciprocal, they'll start kind of giving up. All right, my point is what? Embrace them. Don't start giving up. Understand where the authors come from. If you understand that particular point, you will be able to embrace them better. Okay, let's go next one. Pattern. So I taught you 2 questions on pattern. There's another one. Telescopic type, I call it as a telescopic type. Hey, what happens in a telescopic type? The first few, all the terms get cancelled except few in the beginning and few in the end. All right, that's called as the beauty of a telescopic type. In a telescopic type, all the terms get cancelled except the few in the beginning and the few at the end. That is another kind of a pattern. Telescopic is another type of a pattern that they keep using in the exam. All right, that's another type they keep using in the exam. Let me illustrate this through this example. Let me illustrate. First, let me rewrite this. 3 is common here, right? 3 is common here. There is a 3 here. There is a 3 here. There is a 3 here. Let me take up that particular common. Therefore, you can write this as f of x plus 1 minus f of x is equal to 1 by 3. Is equal to 1 by 3. It's also given to me that f of 1 is equal to 1. Fine, let me have that. F of 1 is equal to 1. But what he wants f of 1000. He has given me f of 1. He's interested in, hey man, tell me what is f of 1000. Okay, put x is equal to 1. Let me put first x is equal to 1. If I put x is equal to 1, I'll write this as f of 2. All right, f of 2 minus f of 1 is equal to 1 by 3. It's a constant function. It is equal to 1 by 3. Okay, I wrote it there. Okay, then you put x is equal to 2. Next, you put x is equal to 2. Then you will write f of 3. Where you are putting that x is equal to 2 in this. This is a parent, right? Everything in this. I'm putting x is equal to 2 in that only. All right, now everything in this boxed one, that's my parent. Put x is equal to 2 where? All right, I'm saying that put x is equal to 2 in this, right? Yeah, okay. So therefore in that boxed one, that's a parent. Everything I'm putting into that. F of 3 minus f of 2. Therefore you're writing this f of 3 minus f of 2 is also equal to 1 by 3 because your outcome is not changing because that's a constant function. We also call them as constant functions. Okay, all right. Put x is equal to 3. In the next one, put x is equal to 3. You write f of 4 minus f of 3 is also equal to 1 by 3. Now this is called as telescopic type. What happens, my friends? Take a look here. This valid now this term f of 2, if you add all of them in a telescopic type, you end up adding them. If you add f of 2 and this minus f of 2 get cancelled, f of 3 and minus f of 3 get cancelled. Likewise, all right, now ultimately you would be saying that put x is equal to 999. When you put x is equal to 999, you write f of 1000 minus f of 999 is also equal to 1 by 3. This is what you ended up writing. All right, this is what you ended up writing. You have cancelled everything except this term and except the first term. Why? Because it gets cancelled in that particular order. This gets cancelled with this gets with this, like that. It goes on, the drama goes on there. So therefore all you will be left in a telescopic is what? Something in the beginning and something at the end will be left out. Okay, how many terms you added? 999 terms, because x is equal to 1, x is equal to 2. Likewise, you wrote 999 equations. Therefore if I add all these equations, what I'm doing, I'm adding them. I'm adding all the equations. If I add all these equations, how many equations I'm adding? 999 equations I'm adding. If I add, what do I get, my friends? I get f of 1000 minus f of 1. These are the only things left. Everything else got cancelled by adding because the terms had plus and minus signs there. They all got cancelled. Is also equal to what? 999 times of 1 by 3, because I have first time 1 by 3, second time 1 by 3, third time 1 by 3. Likewise, 999th time I have another 1 by 3. Therefore, this is what I'm getting out there. This is what I'm getting out there. Good. So therefore, you will say that, okay, this is 3 and this is 3 times. All right, this is 3 times. Good. So thereby, all right, you would say that the required answer f of 1000, all right, f of 1000 is also nothing but f of 1000 f of 1000 is also nothing but 333 plus f of 1. Just get this f of 1 to the other side. All right, plus f of 1, right? Plus f of 1. Okay, what is f of 1? The value is given to me as 1. I substitute, therefore you got your final answer as 334. Simple question, 334. My point is what? Hey, you will get simple questions, complicated questions, all type of questions when you do the telescopic model. It's a model in itself. It's a model in itself. Telescopic model type. Not only in functions, you get this in inequalities as well. You get this in sequences and series as well. It's a model. It's a model in itself. Okay, now when you are doing your mocks, etc., keep your eyes and ears open to this particular model. They may call by this name or they may not call by name, but just keep an eye on this particular model. How do you understand? All terms gets cancelled except a few, couple in the beginning, one or two in the beginning and one or two in the end. Rest all gets cancelled by addition. This is called as a telescopic model, which is one of the popular types used in the exam. Very popular type used in the exam in any form. It can come in the sequences and series, it can come in functions, it can come at multiple locations, but this is a popular type. Remember that. Okay, let's go further. There's another type, equation type. I will come to this. All right, now there's another type called equation type. Let's take a look at this. See, being aware of the types is important. That's my point. I can do many more questions. Because of want of time, I'll not be able to do too many questions out there. But anyway, nevertheless, I will try and give as many inputs as possible. Let me explain this. What is this input type I am talking about? Let me explain to you. What is this input type I am talking about. Right? Okay. So what is this input type? All right, what is this input type? What you do here is, now look, all right, now what you want to find f of 2. What is that you want? You need to know what is f of x. Hey, f of x is equal to ax plus b. Ax plus b. If I know this, okay, a value I will know constant, b value I will know. Then I can find f of 2 because x is there. I can find this. But it is not like this. There is an f of x and there is f of 1 by x. What do you do? What you don't want first? I don't want f of 1 by x. That's what is creating a problem. Had he given f of x is equal to this, oh, I would have allowed it f of 2. I would have directly substituted for the value of x and I would have finished this particular deal. Do precisely the same thing. Now also do the same thing. Yeah, how? All right, let me write this function first. F of x is equal to, f of x plus f of x plus 3 times of f of 1 by x. F of 1 by x is equal to 2x plus 1 by x. This is what is given to me, right? This is what is given to me. All right. So now what I do, what I don't want 1 by x. Now what you do is put, all right, in place of x, put 1 by x. What you don't want, put it. All right, I don't want 1 by x. I don't want 1 by x. Then put x in place of x, 1 by x. Good. In place of x, all right, in place of x, you are putting 1 by x. How does the equation look like? Therefore, in place of x, you are putting 1 by x. Okay. This is 3f. In place of x, if you put 1 by x, it becomes x, my friend. So in place of x, if you put 1 by x, it looks like this. In place of x, if you put 1 by x, it looks like this. Now what I do is I will just rearrange this. All right, I will just rearrange this particular line. Let me rearrange this. What do you mean by rearrange? All right, let me write the first function. Let me copy it here. This is f of x plus 3 times 3 f of 1 by x is also equal to 2x plus 1 by x. Okay, let me write this also in a rearranged format. What is the rearranged format? I will write x under x. This part I will write under this 3 times of f of x. Okay, plus I will write this under 1 by x. This is nothing but f of 1 by x. 1 by x is also equal to, I will write this under this part 2 by x. Okay, plus I will write this final x out here. Good. Now this looks to me something like this. All right, this looks to me something like this. Now I need to solve such that 1 by x get cancelled. How do I cancel 1 by x? All right, you can cancel 1 by x by multiplying the second equation with 3. Multiply the second equation with 3. If you multiply the second equation with 3, this becomes 9. 3 times 9. This will 1 3 times becomes 3. Now this becomes 3. 3 2 times becomes 6. I just did the rewriting there itself. I multiplied throughout by 3. Solve. What do you mean by solve? Subtract the first equation. From the second equation. Just subtract it. If I subtract it, this is 9 minus 1. You will write this as 8 times of f of x. This is plus and minus get cancelled. These two got cancelled, which is also equal to 3x minus 2x, which has become an x. All right, which has become an x. 6x minus 1 by x, which has become 5 by x. All right, which has become 5 by x. Right, which has become 5 by x. Now this is what you end up getting. So they all right. Now therefore, hey, what is f of x? Therefore divide throughout by 8. Therefore you say that this is nothing but x by 8 plus 5 by 8x. Now this is f of x. Okay, now you got it what you wanted. All right, now you wanted. Therefore, can I find f of 2 now? Author is interested in finding f of 2. Yes. All right, f of 2 is nothing but 2 divided by 8 plus 5 divided by 16. 8 into 2. Already 8 into 2. Okay, I can simplify this, no problem on this. All right, now therefore essentially my result would become 9 divided by 16. Already your result would finally essentially become 9 divided by 16. Fine, that's not a worry. Okay, my point here is what? My point is whenever you are given, this is called as an equation type. Whenever you are given something like simultaneous equation, just like solving a simultaneous equation here. Just like solving a simultaneous equation, you got to get it to that particular stage. What is an important step? Algebra method. What is an important step? What you don't want? You don't want to see f of 1 by x. Therefore, substitute in place of x. Replace x with 1 by x. Therefore, put. All right, now this is called as put. Put x with 1 by x. Just put that and go ahead and solve. You will get your answer. That's all the point here, friends. If anybody knows this particular step in algebra, this is closed. This is closed. Without any hassle, it is closed. Okay, I didn't know about that particular step. Then you will be doing research in the paper. And that's what I mean. Right? Generally in algebra, it is all about methods. It's all about methods. There is no madness in algebra. It's all about methods. If I'm clear with my methods, I'm done. I'm done. If I don't know about the methods, I'll be discovering. I'll be sitting there in the paper and I'll be discovering the method. Okay, good. All right, that's a point there. That's a point there. Okay, let me go to the next one. This you do it yourself, guys. Do it yourself, all of you. Push your pens, pencils quickly, quickly. Don't waste my time. Neither yours. Push yourself, push yourself. Do this. Everybody do this. Locally defined function. Locally defined one. Everybody do this. Did that simple one, right? Simple one. I don't think all of you need my help in this. Nevertheless, just in case if anybody is struggling, let me take you through. Let me walk you through. So what you do first, you will get this 3 circle 1. This is the first step, right? Now this is the first step. So where do I go here? I will go here. In place of x, I will write 3. In place of y, I'll be writing 1. In place of x, I'll write 3. In place of y, I'll be writing 1. So therefore, you will say that 3 plus 1 whole square plus 1. All right, 3 plus 1 whole square plus 1, that is 17. All right, you would say that okay, this has given me a 17. Second step, what is the second step? I do this brackets. Say where do I go for the second step? All right, where do I go for the second step? All right, this is the second step here. All right, now this is the second step, step 2. All right, step 2. All right, I will go to this place. All right, this is the step 2. What's the value of x? 2. What's the value of y? 1. Therefore, what is that you are trying to do? 2 cube minus 1 square divided by 2 minus 1 divided by 2 minus 1. All right, that is nothing but 7 divided by 1, which is nothing but 7. Okay, so now I get to know this result as 7. Hey, what is the symbol between them? Symbol between them is this. Okay, now this is the symbol that I have. Therefore, this is my ultimate step. Third step, where do I go for this? I will go to this particular stage. What is c here? X here. X is nothing but 17. What is y there? Y is nothing but 7. So therefore, you will substitute in this x minus y, that is 17 minus 7. And then you would say that 17 plus 7 plus 1. 17 plus 7 plus 1. That's nothing but 10. Right, that is nothing but 10 into 25. Right, 10 into 25, which is nothing but 250. Therefore, you would say that my final result on this particular question is nothing but 250. Some locally defined functions, sometimes you get them in some of the questions. Don't panic looking at those symbols. Hey, what are these symbols doing there? I've never seen something like this in my life. Don't worry. Right, okay, you would have seen or not seen, does not matter what symbols they put. You just apply them, locally defined function, which will be really, really easy. It does not require any pre-knowledge, except that you are BODMAS in the sense, okay, brackets, if any brackets are there, there, that has to be resolved for. At least that much of common sense is expected, nothing beyond that, right? Once we do that, all right, you will get the answers directly from there. Okay, let's get back to the discussion on functions once again. Step functions. All right, now step function, what is that? All right, now, so this is all, sometimes people call this as a ceiling function or floor function. People call this as the ceiling function or floor function. All right, more often than not, now rather than ceiling or floor function, the step function, they'll also call it as the greatest integer function or the least integer function. Greatest integer function, they, you generally find these words, isn't it? Greatest integer function, or you find it as the least integer function. You will also find this as the least integer function. Least integer function. Okay, let me define the greatest integer function for you first. Greatest integer function for 7.8, there will be some symbol, right? Whichever the way, all right, you want to put this up. All right, now let's say that I'll put a symbol like this. Does not matter, different books put different symbols. Assume I put like this. Symbol is not important anyway, they'll explain, because just by putting the symbol they can't expect that okay, we'll be able to understand it. That's not the idea there. They will write it, they will write a symbol. Before writing a symbol, they'll explain, okay, this is nothing but greatest integer function. They will say, hey, what is the greatest integer function here? The greatest integer function, people will have a doubt between 7 or 8. That's a problem. They will have a 7 or 8. All right, now the 7 or 8 between them. Okay, so now there is a 7 here, there is a 8 here. I'm stuck here. This is my 7.8 here where I am at 7.8. There is a 7 and 8. Now listen to this. Nobody will be able to say greatest integer on this side. This side of the number, what is the greatest integer? Nobody will be able to tell. On this side, will I be able to tell the greatest integer? Yes. The greatest integer you encountered before you encountered 7.8 is 7. The greatest integer that you encountered, which means you encountered 5, you encountered 6. The greatest integer you encountered is 7. Therefore, whenever they say greatest integer, you got to look little backward on the number line. You got to look backward. All right, because you can never be able to tell greatest integer that you are going to encounter. You are going to encounter. No. All right, the idea is the greatest integer you already encountered. That is what you can tell. You can't tell what is that greatest integer you are going to encounter. That cannot be told. All right, that cannot be told. Therefore, simply put, greatest integer function means if I put 7.8, my answer is going to be 7. That's it. My answer is going to be 7. You already encountered the best number before 7.8. The best number that you had, best integer that you encountered before 7.8. All right, that is called as the greatest integer. Therefore, by now you got the idea. What is the least integer I'm talking about? Least integer function, if I put the same 7.8. Same 7.8, let me write it something like this. Least integer function. Now don't fall for these symbols. Symbols are nothing to do. Least integer function. Answer again, 7 or 8 will be the answer. Answer is actually going to be 8, because this time you say that a least integer before 7.8. If I ask you a least integer before 7.8, you don't know, because you can go up to minus infinity. Because what is the least integer you encountered before 7.8? No idea, no idea. But will you be able to tell me least integer that you are going to encounter? 8. That's a least integer, because after 8 I'm going to encounter 9. After that I'm going to encounter 10, etc. But what is the least integer that you are going to encounter? The least integer that you are going to come across is going to be 8. You will never be able to tell the other side what is the least integer which you already encountered, that you don't know. But what is the least integer, the smallest integer that you are going to encounter, that you would know. That's simple, guys. That's simple. Therefore, the words themselves are indicative. It's a language. Greatest integer, when they said greatest integer, it is understood which side, because one side you cannot tell. Only one side you can tell. Similarly, when they talk least integer, only one side you can tell. The other side you can't tell. Other side you can't tell. It is pretty logical. The way they coined these words, these phrases are pretty logical in themselves. They're pretty logical in itself. Okay, good. That's a basic understanding. Let's now go back to the question. Let's go back to the question, because I might understand what is greatest integer, least integer, but the point is what are the kind of questions that I get. That's very important for us. First, I need to understand the definition, no doubt about it. After understanding the definition, the task is not done there. The task is, okay, I have to show you some samples. Therefore, knowing that, what I should do, I will show you 1 or 2 samples. I will show you 1 or 2 samples on this. Now we understood these terms. Now let me show you the samples. Let's sample. Read this question to yourself. Just read this question to yourself. A function f of n is defined as something like this for all natural numbers and for all natural numbers. And if f of 1 is nothing but 2, then what will be the value of this entire thing? F of 1, f of 2, or it like this up to f of 50. Okay, what is given to me here? This particular bracket, whenever is putting in this particular bracket, is equal to the greatest integer less than or equal to x. Greatest integer less than or equal to x. You may find that, hey, why did he say less than or equal to x? Now assume that, guys, already if I put in the bracket 7.8, 8. If I put in the bracket 7.8, you are going to call 7. All right, this is going to be 7. That's what you mean by less than greatest integer, less than or equal to x. He has clearly mentioned it, full definition he has given, even if you don't know what is greatest integer function. All right, that's nothing but 7. Okay, what if I have 7.1, 7.1, still 7. What if I have 7.05, still 7. What if I have 7, then also it's 7. That is why he meant by less than or equal to x. What if you are writing an integer in the bracket, in that particular the square bracket, then you call it as 7. That's all he mentioned it. No big deal. He just explained that particular function, what I tried to explain. Right, very gracefully has explained this. Okay, so now let's go over there. Let's go to the function. First, let's go to the function. Let's go here. Let's go here. Let's go to this particular function. Let's understand. What is given to me? What is given to me is f of n minus 1 is nothing but 1 divided by 2 minus f of n. This is what is given to me. Pull that f of n outside. That's better there. So therefore, you may rewrite this as 2 minus f of n is also equal to 1 divided by f of n minus 1. Okay, just rearrange, organize this thought. If you organize it, you will end up by writing f of n is also equal to 2 minus 1 divided by f of n minus 1. Okay, now this is my master. All right, because f of n, already if I have it on one side, it's always handy. It's always handy, more often than not. Without that also you can do, but I just thought that, okay, if I write like that, it would be much more than handy there. Okay, what does it mean to us? Let me rewrite this. F of n can be written as 2 minus 1 divided by f of n minus 1. Okay, this is what you got there. Okay, now let me, I already know what is f of 1. Author has given to me what is f of 1. Therefore, let me find from f of 2 onwards, put n is equal to 2. Let me put n is equal to 2. Therefore, you are writing f of 2 is equal to, why you are not putting n is equal to 1? That's given. F of 1 is already given. Why to find that? F of 2 is equal to 2 minus 1 divided by f of 1. That's what you are writing, f of 1. Nothing but what? 2 minus 1 divided by 2. All it which becomes, all it now which becomes, all it which would become 3 divided by 2. Okay, so now tab it somewhere here, guys. All it f of 1 is equal to 2. What is f of 2? Alright, f of 2 is nothing but 3 by 2. Okay, tab it, f of 2 is 3 by 2. Now put n is equal to 3. Let's go to the same function here. This is my master. Alright, go to the same function. In the master function, put n is equal to 3. If I put n is equal to 3, f of 3 is equal to 2 minus 1 divided by f of 2. That's what you would be writing. That is nothing but 2 minus, alright, 2 minus 1 divided by, what is f of 2, friends? 3 by 2. Alright, 3 by 2. This is what you will be writing here. Alright, that's what you would be writing here. Therefore, that would become 4 divided by 3. Ultimately, it becomes 4 divided by 3. Let me tab it here. Therefore, f of 3 is equal to 4 divided by 3. Now see, with 3 terms, you should get a pattern. Already, you should be able to define a pattern. Those who understood it, you would have defined the pattern already for yourself. This is nothing but 2 by 1. Simple, friends. When I'm writing f of 1, write this 1 and increase it and write it here. When you're writing f of 2, write this 2, increase by 1 and write it here. When you're writing f of 3, write this 3 and increase it and write it here. Fine. Therefore, I got my response here. Therefore, I wanted to understand what is f of 1. First, let me write f of 1, and I wanted to write f of 2. I wanted to write f of 3. Like this, I wanted to write up to f of 50. I wanted to write f of 50. That's a job there. What is f of 1? F of 1 is 2 by 1. What is f of 2? F of 2 is 3 by 2. What is f of 3? F of 3 is 4 by 3. Okay, like this, what is f of 50? 51 by 50. This is what you do there. All right, that's what you do there. But the job is not over with that. Already you have to find the greatest integer function for them. But the job is not to add this. A job is to add greatest integral values of this. So therefore, I have to put a greatest integer value for this, greatest integer function for this, greatest integer function, integer value which came before this. Okay, therefore, when you're writing the response, you say that, hey, this is 2 here, this is 2, and this is going to be 1, 3 by 2. 3 by 2 is 1.5. All right, now 4 by 3, that is also 1. 50 by 51, that is also 1. So therefore, all are 1s except the first number, which is 2, which means 49 ones are there. This is 1, this is 1, this is 1. 49 times you wrote 1. Only the first time you wrote 2. Therefore, the response is nothing but 51, because the first outcome was 2. After that, every other outcome was 1. After that, every other outcome was 1. There are 50 outcomes here. So 49 of them are 1s except the first one being 2. Therefore, the overall response has become 51 for this particular question. Simple. All it is a step function. Basically, you need to understand that, okay, so how do I understand the greatest integer function? Sometimes they may talk about the least integer function as well. Whether they talk about the greatest integer or least integer, once you are clear with the definition, you'll be able to work through those particular questions. Let's take one more cat question built on this. Let's take one more cat question. Beautiful one. Take a minute, friends. Everybody take a minute. Try to work through this. Take a minute and think about it. Such a beautiful cat question. Such a beautiful cat question. Okay, now do the rest of it with me. So here we go. So what is given to me? So basically, all right, now, so what is this bracket? We already know this. That's a greatest integer function. That's a greatest integer. Yeah, what is this particular bracket? That's a fraction part. All right, now if I do y minus the remove integral part, all right, for all positive real numbers, if I remove that, what do I get? I get the fraction part. Listen to me carefully, friends. What I meant is this. If I have 7.8, say that this is my y. The y is equal to 7.8. Yeah, what is the greatest integral value of this? The greatest integer value of this is 7. Well, it's 7. Okay, what is this flower bracket here? What is this flower bracket? Flower bracket is y minus greatest integer value. That is what he said. Okay, so therefore that is nothing but 7.8 minus 7, that is 0.8. Technically what I'm trying to say is, yeah, there is an integral part and there is a fraction part, and there is a fraction part. Both put together is what? Y. That's it. There is an integral part and there is a fraction part. Put together becomes my number. That's all author tried to say in the first statement. If you read till here, that's all author is trying to say, nothing beyond that. He said that, man, I'm giving two different brackets. One part is an integral part, the other part is the fraction part. He's just trying to communicate that thought. He's trying to communicate that thought. Okay, second, all right, second from here. How many solutions? Question. Therefore, how many? Count how many solutions does this particular equation have. All right, now, so how many solutions does it have? Fine, let's take a look here. All right, now knowing this, all right, having understood this, let's take a look. So therefore what is given to me? 11 times of integral part of y. Listen very carefully, all of you. Plus 23 times of the fraction part of y. 23 times of the fraction part of y should be equal to 250. I want to understand that, therefore y can take how many values. All right, that's the whole idea of this particular question. Very good. Now listen to me, guys. In a single number, in a single value of y, in one value, let's say that y has taken one value, right? In that value of y, all right, what can be the value of the fraction? What can be the fraction value in that y? It can be 0 to less than 1. You will write something like this: 0 included, 1 is not included. In the sense, when you write this 1, what if I write it as 7? If I write it as 7, then the flower bracket y, the value flower bracket y, this y is nothing but 0. There is nothing in that flower bracket. What is the fraction part in 7? Nothing. Fraction part in 7 is nothing. If you write y is equal to 7.8, then the bracket, all right, now what is this flower bracket y? It is nothing but 0.8. It is nothing but 0.8. So therefore I'm writing that it's a closed interval 1. It can never be 1. It will be closed interval 1. In the sense, what if y is equal to 7.999? Or then you are trying to say that the flower bracket y is also nothing but 0.999. That is what becomes the flower bracket. Therefore I'm writing this as something less than 1. Something less than 1. It cannot be 1. But can it be 0? Flower bracket, square bracket, yes, it can be 0, but it cannot be 1. It should be slightly less than 1. It can be slightly less than 1, which means what is the range? Range is 0 to 1. Very good, guys. Now take the full stuff here. Therefore what will be 23 times of y? What will be 23 times of y? Full bracket, I'm writing it here. Therefore the 23 times of y will be 0 into 23 and 1 into 23. It cannot be 23, something less than 23. It cannot be 23. It can be something less than 23. That's it. Because if it's for one observation, if it is 0 to this, if you multiply by a coefficient 23, then this value will become something like this. All right, now 0 to 23. All right, 0 to 23. Good, guys. Now take a look at this. Therefore, all right, now what will be the value of this? Therefore, what would be the value of this? What would be the value of this? If 23y, the red one, if 23y can take the values from 0 to 23, all right, what are the values? 11y should take that. The 11y should take, when it is 0, when this is 0, then the 11y should be taking the entire 250. The 11y should be taking entire when this is 0, because why? Because the sum is 250. The sum is 250. When the 23y is 0, then where the 250 is coming from? The 250 is coming from 11y. The 250 is coming from 11y. Okay, now similarly here, when this is 23, what was the value? 11y was taking, not y, the entire 11y, my friends. Entire 11y I'm analyzing, right? Therefore you will say that a 250 minus 23, because this has already taken 23. Best value it can take is what? Slightly less than 23. In your mind, take 23. 250 minus 23, 227, greater than. Therefore you will write the closed bracket. All right, therefore you write the simple bracket, 227 to 250. But the point here is 11y is a multiple of 11. This 11y is a multiple of 11. Question is very simple. How many multiples of 11 exist in this range? How many multiples of 11 exist in this range? 11 into 20. 11 into 20 is 220. 220, that is not in this range. 11 into 21, all right, that is nothing but 231. Okay, 11 into 22, okay, this is the benchmark, this flashes in your mind in no time. 11 into 22, which is nothing but 242. Okay, 11 into 23, all right, which becomes 253. Now 253 is out of this range, this is out, because all right, now so I have only till 250, that's out. Therefore all right, I can have 242 as one number, 231 as the other number. How many solutions? Therefore only two solutions, that's it, over. Such a simple question, on this integral solution. Two values it can take. Why? Because the 11y has to be here, this 11y has to be an integer, natural number, because y is nothing but the natural number. Y is a natural number here, because that is nothing but the integral part of the fraction, integral part of the number. So if it is an integral part of number, 11y can take 231, or at 11y can take 242. Okay, you may wonder that, okay, if it is taking 231, how it is becoming 250? The rest of it is taken by the fractional part. 23y is giving you that fractional part, or at 23y is giving that fractional part. If this is taking 242, then from where the remaining 8 is coming from? That is coming from your 23y. 8 is a part of this, okay. And also if it is taking 231, 19 is a part of this. Does 19 lie between 0 to 39? 23, yes, solid, that automatically is taken care. Such a simple nut. You just have to understand that how do I write these ranges, which I already taught you in the inequalities chapter. I spoke about these brackets. I taught you in the inequalities chapter. Had you just analyzed it well, all of this takes just about a minute to solve, maybe a minute to understand this question and a minute to solve this question, right? That's about this particular question. Fair enough, guys. Let's go for the last 15-20 minutes. All right, another 20 minutes. All right, we have a couple of things to cover. There is a lot more to cover. There is no end to this, but let me cover as much as possible. There is a lot to cover. Okay, yeah, let's come to this. Let's understand the domain and range. I already told you something about this function. Right? I already told you something before. What do you mean by domain? All right, what do you mean by the word domain? The values x can take. I told you in the beginning. The domain is nothing but the values x can take. The values x can take is called as the domain. Okay, so therefore I need to look at this particular function and I need to say that, okay, what are the values x can take? Domain is one of the common questions, or there's another kind of question that may come in the exam, right? Therefore you will say that, okay, what is the function here? Y is equal to f of x is nothing but y, my friends. Therefore y is equal to log x plus 3 to the base 2 log x plus 3 to the base 2 divided by x square plus 3x plus 2. X square plus 3x plus 2. This part, denominator part, I taught you in the denominator part. I clearly taught you when I was talking about the inequalities chapter. All right, that was clearly taught there. Okay, therefore let us put it to perspective. And the logarithm part I already taught you in the logarithm chapter, because the input to the logarithm has to be positive, right? Input to the logarithm has to be positive. Let me rewrite this first. Log x plus 3 to the base 2 divided by x square plus 3x plus 2 can also be written as x plus 1 and x plus 2. Okay, now I know that. Okay, so now I know that x cannot take the value 1. X cannot take the value 1 here, my friends, from here, because denominator cannot be made 0. Therefore x cannot take the value minus 1 and x cannot take the value minus 2. That's clear. X can take from the denominator. I analyze the denominator. What I'm doing here, by analyzing, I analyzed my denominator. Analyze. Hey, there is nothing like it should be greater than this, less than this, nothing. Analyze denominator. Your denominator cannot be 0. Denominator becomes 0 for a value of x being minus 1 or the value of x being minus 2. Therefore what you are trying to say, by analyzing my denominator, I say that, hey, x should not be given an input of minus 1 and minus 2. Good. Okay, now similarly go to the numerator, my friends. Understand the logarithm. So what is that logarithm? The input to the logarithm has to be positive. It is not x being positive. The input, that x plus 3 should be positive. Okay, let me analyze my numerator. Therefore x plus 3 should be greater than 0. Therefore x should be greater than minus 3. Therefore you are saying on the number line x can take any value greater than minus 3. Good. X can take any value greater than minus 3. Till where? Till infinity. X can take any value greater than 3. Okay, therefore most likely choice here is nothing but D. Alright, it can take any value from minus 3 to infinity except flower bracket. I explained all these brackets in the inequalities chapter. You are confused between between the type of brackets. Hey, when I'm using this, why I'm using this sometimes, why do you use the flower bracket sometimes. I referred to this in the beginning of my inequalities lecture. All right, now please refer to that. Okay, now accept all the values, except what, my friends? Except -1 and -2. That is what is represented by this particular thought. All values between -3 to infinity is fine. Exceptions being, hey, somewhere you come across -2, somewhere you come across -1. I saying that, okay, don't input these values, because if you input these values, the denominator becomes 0, then the outcome becomes indefinite, right? Infinite or indefinite. All right, therefore you would say that I should not give the values of -1 and -2 for the values of x. Other than that, any value between -3 to infinity is fine. That's about the domain. So point here is, domain means what? The values x can take. How do I understand this? You got to analyze the question stem. You got to analyze the given function. You got to analyze every part of it. You are analyzing the logarithmic function here. You are analyzing the logarithmic function here. You are analyzing the quadratic function here. And then you are mixing that composite. You are putting that analysis together. That's how you determine the domain of a particular function. One more. Let's do one more. Let's do one more here. Let's do one more just to give a little more clarity. Let's try one more here. Let's try one more. Okay, the domain of this particular relationship, there is a relation here, the domain of this. So whenever you're writing, okay, another important point, when you write a domain, ensure that you always write it as y is equal to something. Whenever you want to find a domain or a range, whatever you want to do, you always write y is equal to everything in terms of x. Write this side in terms of x. You cannot have a mixed function there in terms of x. You got to write the other side in terms of x. Okay, now look at this. Was it like that? Yes, it was like that. Y is equal to, all right, it was already like that. Therefore I did not bother too much about it. All right, no, that was already like that. All right, this was already like that. All right, it was already given to me. Y is equal to something. It was given to me. But look at this particular function. These are called as implicit function. This is called as explicit function. All right, this kind of functions are called explicit functions, whereas these kind of functions are called implicit functions. Why I'm calling? So now look at this. Everything is mixed up. Everything is mixed up. X, Y, everything is mixed up. But what you got to do? You got to explicitly write like this. Y is equal to something, and then you should do your analysis. Not that, okay, you simply started doing analysis on everything and anything. No, all right, you got to separate the entity. This is the standard form. Put them in this standard form, and then you better analyze. Okay, let me take up this. Therefore, let me take this up. So how do I write this? You'll say that y square is equal to 2 minus 2x. Okay, therefore y is equal to under root of 2 minus 2x. It looks like this. All right, y is equal to under root of 2 minus 2x. Now, is this in the original form? Yes. Now this is the better form. This is the better form. This is the form that I wanted. This is the shape. All right, this is the type. All right, this is the shape that I want. This is the shape that I want. I got that kind of shape. Y is equal to something. Now you analyze. Hey, what do you know? Under root of something has to be positive. Under root of something, whatever you give the input, not x, under root of anything has to be positive. Because if you write under root of something, see, that's a knowledge part. That's a knowledge part in algebra, right? If you lack that knowledge, then you will never be able to get the domain and range of the function. See, logarithmic function, the input has to be positive. The root function, the input has to be positive. That knowledge part has to be clear. If that is not there, then we'll not be able to find the domain, range, etc., etc. That may not be possible. Okay, now under root of negative becomes an imaginary number. Y is not imaginary, Y is real. Therefore, what should the input? The input has to be positive. Therefore, you are saying that, man, okay, so analysis 2 minus 2x has to be greater than or equal to 0. Positive 0 is also fine. Under root of 0 is also fine, not a worry. Therefore, it has to be greater than or equal to 0. Therefore, let's say that, all right, therefore you will say 2x is greater than or equal to minus 2. Subtract 1 both the sides. Now multiply by minus 1 on both the sides. I taught you in the inequalities chapter. If you multiply by minus 1, the inequality will change. All right, this inequality shape will change. You write this as you write this as less than or equal to 2. All right, therefore you say that x is less than or equal to 1. Therefore finally you write this as x is, all right, therefore you finally write it as x is less than or equal to 1. You write this here, less than or equal to 1. X is less than or equal to 1. What does it mean? On the number line, there is a value 1 here. It can take all the values less than or equal to 1. 1 is also fine, and it can go up to minus infinity. So where is this choice? All right, clearly depicted. It is clearly mentioned in the choice D. All right, it is clearly mentioned in the choice D. Right? Yeah, that's all right. That's what you kind of, all right, that's what you mean by this particular. All right, that's what you mean. These are the values that x can take. Okay, so let's now go to the range. Okay, that's about the domain. Let's understand the range. Range means what? The values that y can take. Now, what is the range? Range is nothing but the values. Range is what, guys? Range is nothing but the values y can take. All right, there's nothing but values y can take. values y can take. Okay, analyze for the value of y. Therefore, let's analyze for the value of y. Let's take up this particular function. Let's take up this particular function. What is given to me? Y is equal to x square plus x plus 2 divided by x square plus x plus 1. Now look, you are not able to factorize this. You may wonder, am I able to factorize this? Of course not. You can't factorize this. You can't factorize the numerator, neither you can factorize the denominator. Factorize, you cannot do the factorization. That's another thing that can happen in the exam, right? Because we bank so heavily on factorization, sometimes you realize that, man, the factorization is not possible. That's fine. So that's what I'm trying to teach out here. All right, that's what I'm trying to teach. Don't panic whenever the factorization is not possible. There must be a way out. All right, that's how they might have given the functions. What I do, all right, this can also be written as x square plus x plus 1, all right, another plus 1, another plus 1 divided by x square plus x plus 1. Why did I do that? Because in the denominator I'm seeing plus 1, therefore the numerator I've conveniently split like this, okay. They will always give a way out. Don't panic, they will always give a way out. You just have to be mindful about getting that particular way out. That's what the beauty of algebra is about. All these are methods, guys. All these are the methods what I'm talking. Okay, so therefore from here you will do what? Split and rule this by what? X square plus x plus 1 plus 1 plus what? 1 divided by x square plus x plus 1. That's what you write it here. Hey, what is this one? What is the first portion? First portion is 1. Therefore, you are saying that 1 plus 1 divided by x square plus x plus 1. Therefore, you are finally writing y is equal to, listen, y is equal to 1 plus 1 divided by x square plus x plus 1. That's what you are writing. That's what you are writing. In the sense, now look at the denominator. Denominator is always positive. Denominator is always positive. You can never make the denominator negative. You may wonder, how do you know, man, the denominator is always going to be positive? I'm talking very pure algebra here, friends. Now look at this. All right, now you take up this particular function x square plus x plus 1. Find the discriminant d. Discriminant is b square minus 4ac. All right, find the discriminant here. Discriminant is b square minus 4ac. Discriminant. All right, now discriminant of b square minus 4ac. All right, b square is nothing but 1 minus 4ac. All right, minus 4. That's nothing but minus 3. Discriminant is minus 3, which means what? The parabola. I told this in the quadratic equation chapter. Please go back to that quadratic equation. Towards the end of it, I've drawn all these graphs. All these graphs I've drawn. Whenever the discriminant is this, all right, discriminant, the roots are imaginary. What do you mean by roots are imaginary? The graph is up like this. The graph is up like this. The graph is up like this. Hey, what do you mean by graph is up like this? It is above the x-axis. Above the x-axis means what? Every value of y, already every value of y is positive. Every value of y is positive, because it can never, if the graph comes down like this, then there will be some values of y which will be negative. But in this case, every value of y will be positive. That's what the importance of discriminant is. Therefore, you would say that, okay, therefore this is always positive. One look at this, I know that this is going to be positive. All right, this is positive. Therefore, what you are trying to say, y is equal to 1 plus 1 divided by positive value. If it is 1 plus 1 divided by positive value, minimum value of y, therefore the minimum value of y is nothing but 1. Nothing but 1. Why? How do you make it minimum value is nothing but 1? Because you understood that the denominator is positive. Put x is equal to 1 lakh, guys. Put x is equal to 1 lakh. 1 divided by 1 lakh whole square plus x divided plus 1. All right, 1 divided by 1 lakh. 1 divided by 1 lakh itself is 1.000. So many zeros you'll be writing. Therefore, it will be very, very close to 1. All right, that's a minimum value. That's a minimum value. Therefore, if you look at your answers, everywhere there is 1, because they know that it's a cakewalk. Getting 1 is a cakewalk. Getting 1 is a cakewalk. The minimum value of y is going to be 1. But the point is, what is the maximum value therefore? What is the maximum value therefore? Why the minimum value is 1? Take x is equal to 1 lakh. Simply put x is equal to 1 lakh. 1 lakh is 1 divided by so many zeros whole square. All right, 1 lakh whole square. Forget this x plus 1, etc. So whole square. Nothing but what? 1 plus 0.0000 something. Nothing but so very close to 1 open bracket. Okay, that is the minima. Now let me find the maxima. Let me find the maxima. All right, let me find the maxima. How do I find the maximum value of this? Now look at this. Already you know the denominator part. Denominator, guys. All right, if I want the maximum value of y, if I want y maxima, listen carefully. If I want the maximum value of y plus, I want 1 divided by x square plus x plus 1 to be minima. All right, I want this. All right, I want this to be maximum. This entire bracket to be maximum. This entire bracket has to be maximum. If the entire bracket has to be maximum, the denominator has to be minimum. The denominator has to be minimum. because numerator is a constant. Look at that, 1 divided by something has to be maximum. Therefore, what does it mean? It means that the denominator has to be minimum. All right, if the denominator is minimum, the fraction value becomes maximum. Yeah, what is the minimum value of this, guys? So we all know that. All right, if it is a parabola, which is lying above this, there will be a minimum value which comes here. There is a minimum value which comes here. What is the minimum value? I told you in that quadratic equation chapter, towards the end of the chapter, I did maximum minimum. It will have its x coordinate, it also has its y coordinate. Hey, what is the x coordinate? X coordinate is nothing but minus b. X coordinate is nothing but minus b divided by 2a. Hey, what is the y coordinate? The y coordinate is nothing but 4ac minus b square. 4ac minus b square divided by 4a. All right, we talked about this. Now this is what I'm interested in. All right, this is what I'm interested in. This is the minimum value. This is the minimum value. Why? Because this is the bottommost point. Bottommost point is nothing but minimum. Am I talking about x or am I talking about y? I am talking about y. Therefore, I will take this. I will take this and I will work on this. This is the minimum value. This is the minimum value. Substitute, my friends. Substitute. Therefore, that's a minimum in the denominator. For the denominator, I am talking. All right, that's a minimum value that y can take. Substitute for this. 4. The value of a is 1. The value of c is 1. The value of b square is 1 square divided by 4 into 1. Okay, that would become how much there? All right, now that would become 3 by 4. That would become 3 by 4. Where I should substitute in this green value. In this green value. Therefore, y maxima is equal to 1 plus 1 divided by 3 by 4. 1 divided by 3 by 4. All right, that would essentially become 7 by 3. That is nothing but the y maxima. Y maxima is 7 by 3. Do you mean it can take 7 by 3? Yes, it can take 7 by 3 because that point lies on the graph. It can take. Therefore, the answer becomes C. The answer becomes C. It cannot take 1, that is the minima, but it can take 7 by 3. Now look at this, how beautifully we have converged. All right, we are analyzing it because we know the quadratic. All right, now we know how the graph works like. See, all this you don't have to draw in the exam, but it should be lingering in the back of your mind in the exam. I'm trying to bring a clarity there. How do you analyze a quadratic expression? How do you analyze a logarithmic function? How do you analyze a root function? Now this is how you get the domain and range. Domain and range is nothing but having an understanding about the different kind of functions. It can be a logarithmic function, it can be an algebraic function. If you know about them, then you'll be able to find the range and domain of this. Okay, I showed 3 examples on domain and range put together. I hope all of you got some perspective about this. All of you got some perspective about this. Okay, so I will do one bit of it. All right, as I go along, I will do one bit of it. I don't think I have too much of time for the graphs today. All right, I don't think I have too much of time for the graphs today. I will do maxima minima and I will close with that. All right, I will do maxima minima maybe 10 minutes. Then I will close with it. 2 types of functions you will get in maxima minima. One, you will get linear functions. Last topic, guys, last topic. Because of want of time, I will not be taking up the graphs. I've taken sufficient number of functions. I gave the idea here. We started with counting the functions, and then we talked about the various patterns in the functions, right? Various patterns in the functions. All right, then we are now talking about, all right, then we talked about the inverse function, which was one of the important ones, right? Inverse of the functions, self-inverse functions typically, right? And then let's also do this. Then we talked about the domain and range. Now we are talking about the maxima and minima. Another 10-15 minutes. Another 10 minutes, we should be done through with this. Now, 2 things. One, it can be a linear function. 2 things we'll get. One, it can be a linear function. The other one, it can be a quadratic function like this. It can be a quadratic function. What can be the third one? A combination of linear and quadratic function. This is a quadratic function, 2 quadratic function. The third one could be a combination of linear as well as quadratic. Now, this is what you commonly see it in the exam. All right, these are the kind of things what you commonly see in the exam. You may be wondering that, okay, all right, yeah, I just have to equate them and solve. That's correct. That's correct. What you are thinking about it is pretty correct. All right, pretty correct. Okay. Now, what is this technically? What is this technically? Maximum of a minimum of a function. Let me explain this to you. Let me explain this so that it will be very clear. Even if they put a trick on this particular question, you'll be able to solve them. Firstly, now this is one function. Y is equal to, this is one function. This is one function. This is another function. This is a way of representing the thought, which means my first function is y is equal to 5 minus x. This is 1. All right, this is my first one. What is the second one? Y is also equal to x plus 2. That's the second one. From where I'm writing from here. Y is equal to 5 minus x. Y is equal to x plus 2. These are the 2 functions that I'm writing. What are these functions? Linear lines. These are the lines. Technically, these are nothing but lines. Okay, let me draw them. All right, let me draw this particular line. Let me put the axis and draw the lines. Let me draw the lines. Now, let me call this as line 1. What is this line 1, friends? This line 1, put x is equal to 0. Y is equal to 5. Y is equal to 5. Put y is equal to 0. 0. Let's put y is equal to 0. If you put y is equal to 0, x is equal to 5. Okay, you got 2 points. Please draw that particular line. Let's draw that particular line. Call this point as 5. Call this point as 5. This is my first line. All right, therefore this becomes my first line. All right, this is my line 1. Come to line 2, guys. Come to line 2. Come to line 2. Put x is equal to 0. If you put x is equal to 0, y is equal to 2. Put y is equal to 0, x is equal to minus 2. X is equal to minus 2. Let me call this as x is equal to minus 2. Let me call this as y is equal to 2. This is my second line, which is passing like this. All right, this is my second line. This is line number 2. Now look at this. What is that author wanted here? Maximum, which means trace the graph which is the maximum at any point in time. I'm tracing it now. This is the maximum. Upper portion. Trace the upper portion. All right, why I'm tracing the upper portion? Because the word is maximum. Okay, you traced all the upper portion. Already you have to trace the better portion, right? You traced it. After this, what you should do? Now find minimum of this traced portion. Now he's saying that, hey, now that you have traced it, why don't you tell me the minimum possible value of this? Fine. Hey, what is the minimum possible value? Minimum possible value is nothing but this point where I've circled it. This point. Already it is nothing but this point. This point is nothing but what? Intersection of line 1 and line 2. Point of intersection of line 1 and line 2. What do you mean by point of intersection? You just have to solve these two simultaneous equations. That's it. The one way of solving is 5 minus x is also equal to x plus 2. 5 minus x is equal to x plus 2. Why? Because both of them are y's only. All right, therefore all right, no, because we know that concept of it is point of intersection, you solve it as 5 minus x is equal to x plus 2. Good. So if you solve it, 5 minus x is equal to x plus 2, 2x is equal to 3. Therefore x is equal to 1.5. But the point is, am I interested in the value of x or am I interested in the value of y? You should be very clear. You are interested in the value of f of x. What is the meaning of f of x, my friends? Why? Don't give 1.5. There is 1.5 here. Don't take it in a hurry. That is the value of x. That's how they con us. They will give the value of x also. They'll give the value of y also. You be mindful what is that being asked. What is asked is find the value of f of x. F of x means what? Y. You should give the value of y. How should I give the value of y? Substitute in one of the equations. You may wonder which equation. How does it matter? Any equation, because x coordinate of the point is 1.5. Any equation you put, you will get the same y coordinate. What is the y coordinate? Therefore 3.5. Or it put x is equal to 1.5 in this. You're writing it as 5 minus 1.5. Technically it becomes 3.5. All right, now this is the value which is required there. Therefore, whenever such questions are given, what we generally do, what our teachers have generally said, hey, equate it and solve and finish the deal. Equate it, solve, you get the value of x. Once you get the value of x, go substitute in one of the equations and finish this particular deal, right? Okay, this is the framework. This is the framework behind this, isn't it? This is the framework. All right, let's go to a quadratic one. Let's go to a quadratic one here. Let's go to a quadratic one. Let's see this. All right, the first one. Let's draw this particular graph. First one is what? Y is equal to, he has given two graphs here for us. Right, he has given two graphs for us. Y is equal to x square minus 7x. Okay, first graph is this. I'm drawing it, all right, so that you will have a clarity as well. It may help in your graphs chapter also. All right, that's a point there. All right, while you are doing the graphs also, you will know that what to draw, what not to draw. Therefore, I'm just taking that liberty to draw as well. Without drawing also, these questions can be solved. That's a different issue. I'm showing you so that there is a clarity. Even when you are doing certain graphs, there would be some clarity there. Okay, y is equal to x square minus 7x. How do you write it? That's one equation. All right, this is the one equation. What's the second equation here? Y is equal to 9 minus x square. That's the second equation. All right, that's the second equation. How do I write the first equation? Y is equal to x times of x minus 7. And therefore, what are the critical points? One of the critical points is 0. Another critical point is 7. All right. If I'm drawing this particular graph, how does my graph look like? Let me make an effort to draw this particular graph. One of the critical points is 0 here. One of the critical points is 7 somewhere here. So the graph, the parabola goes through these two particular points, something like this. All right, this is how the parabola is going. All right, this particular point is 0 and this particular point is 7. All right, that's how the graph is going here. That's how the graph is moving. Very good. All right, let me take a look at the second graph here, my friends. Let me take the second graph here. Y is equal to 3 minus x and 3 plus x, because it is 9 minus x square. All right, 3 minus x and 3 plus x. What is one of the critical points? 3. What is another critical point? Minus 3, because x plus 3 is equal to 0. Minus 3 will write. Okay, so let me drop those critical points. 3 can be somewhere here. All right, this could be a point 3. All right, this could be minus 3. Okay, now this parabola will be facing downward. All right, this parabola would be facing downward, not upward. Why you say it faces downward? Look at the coefficient of x square. If the coefficient of x square is negative, the parabola opens downward. Therefore, this particular parabola would be coming like this. All right, this particular parabola would be coming like this. Good. Now what is that author is saying? Now this time the author is saying that okay, hey, trace the minima, man. He's saying that trace the minima. Trace the minima means what is that you are trying to trace? All right, you would be tracing these particular lines. I'm tracing it here with a blue line. Minima. Minima means earlier you trace the maxima. This time you are tracing the minima. All right, I am tracing this minima. Okay, I'm tracing this minima. This is the minima. These are the traced lines. Now what is saying? Okay, whatever you have traced the minima, right? That's correct. Whatever you have traced, I want you to get the maximum value of this. Where is the maximum value of the traced value is coming? It is coming here. It is coming here. In fact, you get 2 points. You get 2 points. All right, you get 2 points. But the maximum value of the traced point is coming here. All right, this is the maximum value which is coming here. This is where the maximum value of y is coming out of the traced values. All right, where the intersection. Therefore, nothing but what? This point is also nothing but intersection of two lines, to intersection of two curves. Therefore, what you should be doing? Solve. Therefore, you say that here also you solve it. That is x square minus 7x is equal to 9 minus x square. Therefore, you solve it here. Therefore, you say that 2x square minus 7x minus 9 is equal to 0. You are solving because you are looking for the points of intersection. You are looking for the points of intersection. Therefore, you will get the roots. All right, you will get the roots as 9 by 2 as one of the values. All right, one of the values. One of the values. All right, because 9 2 times is 18, isn't it? 9 2 times is 18. That works out with 7. But then you will write this as 9 by 2. All right, 9 by 2. And then you will write as 2 by 2. That becomes minus 1. These are the roots. One of the roots is minus 1. Another value of x is 9 by 2. 9 by 2 is nothing but 4.5. All right, 9 by 2 is nothing but 4.5. Now look at this. This is the value of 4.5. This is the value 4.5. X is equal to 4.5 gives the minimum value here. All right, gives the lower value here. That is not what I'm interested in. X is equal to minus 1. This is the value, guys. X is equal to minus 1 gives me the better value of y. X is equal to minus 1 gives me the better value of y. Therefore, I will take minus 1. I will plug it here. Put minus 1. 9 minus of minus 1 whole square. I'm plugging in this. 9 minus of minus 1 whole square. All right, which becomes 8. All right, which becomes 8. 9 minus 1, which becomes 8. Answer is none of these because the required answer is nothing but 8. I hope all of you got the idea behind this particular question, what I meant by graph tracing. Okay, in the exam, don't try to trace the graphs, etc., etc. All you do is just do this portion. In the exam, do this portion. Why this graphs etc. is required? It is required. Sometimes the question become way too critical. You will not be able to decide without drawing the graphs. That's a different issue altogether. Alright, if there is a time which permits towards the end of it, I will take 1 hour on the graphs itself. Probably I will let 45 minutes on graph itself. I will mix it up with some other chapter. Let's see. Alright, if there is a time permits. So when I do that, I will tell the importance of this. I will tell the importance of graphs. Alright, for now, that is it from my end. I hope all of you appreciated, all of you have learned something through this particular lecture of the last 2 hours. All right, God bless. I will see you in my next lecture. Bye till then.